We should be live. Welcome to the show. I'm your host, Brad the Bard, and today joining me is Earthican Man, Elan Lift from Planet Earth, obviously. We're coming at you guys from the
from here on Earth?
From here on Earth.
As we float around in space.
The space station. And I just want to give a shout out before we begin to Vedinian. He is the sponsor for the show today. If you guys like creative writing, horror, and sci-fi, check his website out at the bottom. Really good stuff there. So what's up, man? It's
Hello.
Good to finally have you on the show.
It's been a while that we've been trying to do this, so finally we are together to do this.
It's pretty hard to line up a trip to space, so, you know.
The costs are phenomenal.
Speaking of the costs, I see Tesla's just got done doing their launch in Texas the other day. What's your take on that whole situation? It looks like it was a successful launch till the landing.
Well,
they had a little bit of a snafu there.
It was a successful test. It was the first Starship test of a full-scale mock-up. What you have is a space company who is building out of steel for the skin of the rocket instead of some whatever
titanium or something, I would imagine.
Aluminium,
if you're British.
Carbon composites, things like that. So he's flipped the script to build Starship, and as the 8th iteration of it, they already took off, did a small hop. They already did a higher hop up to, I forget, 150 meters, something like that.
Yeah.
So a little bit higher off the ground with a single engine. This test was the first 3-engine test, and it went up, it belly flopped, so it spread out that surface area,
and
so
that
it
was
slows down through the atmosphere.
That was an intentional thing,
exactly.
Right?
So looks like a plane without wings when you orient it sideways, but remember, the space shuttle did land like a plane, an unpowered plane. It had rocket motors on the back, but it didn't have, any jet engines. It didn't have the ability to run in our atmosphere. Using the oxygen, that's what jets and planes do. They're using the air. And the shuttle was strictly for space, but they wanted it to come down and land like a plane on a runway. So they did that with the shuttle. And while the shuttle is a fantastic vehicle, it can't be replaced. But it was a lot of complex stuff thrown together, where Starship is purely a rocket. It goes up like a rocket. It belly flops, again, spreading out that surface area. If you can imagine sticking your hand out the window, edge on.
More drag.
You cut through the air. And then if you put your face out towards it, the face of your palm or anything like that, you're spreading that out. So it slows it down more quickly. So it'll take no active propulsion to slow it down when it re-enters an atmosphere. And an atmosphere means that it's headed for maybe Mars, maybe Titan. Maybe we'll see something else. So Starship is an exciting
Titan
thing.
is the moon of Jupiter?
Saturn.
Yeah,
Saturn. The largest moon on Saturn is Titan. And Cassini dove into the body of Saturn in 2017, but let off the Huygens probe. Basically, we sent a robot through the only moon with an atmosphere, through the atmosphere there, and it landed on the bank of a lake. But the lake was not water, it was liquid methane.
Oh.
So basically, you have Starship running on methane. Now, this new rocket motor is running on methane. So it's sort of like a gas depot to be, maybe eventually.
Interesting.
Yeah.
That's a curious case about the methane thing, because is liquid methane as flammable as the gas?
Liquid methane is just super cold. I think if you just have the oxidizer, it may not be as efficient as if you heat it up, but rocket motors are really complex. And I believe as a full flow stage combustion engine, the Raptor engine, warms it up before they throw it in the chamber. I am not a rocket scientist, but I am an enthusiast. I love what SpaceX is doing. And if they can build cheaper rockets with more capability, I'm all for whatever they're doing. And hopefully they do it responsibly.
Yeah, definitely.
Looks good.
So what? Maybe you don't know the answer to this, but why Titan and not isn't there another planet that has a moon that is basically all water?
Sure. I believe Europa has.
That's the one I'm thinking
Jupiter
of.
has Europa.
Yes.
And also Saturn has Enceladus. So 2 icy moons, possibly warm thermal vents at the bottom of these oceans, of salty oceans, not unsimilar to the ones that we have here on Earth.
Yes.
And there are like extremophiles, life forms that can survive in those extreme environments.
For sure.
And so maybe there's a chance. Maybe there's life there. Maybe there's not. Maybe we bring it if we don't sterilize our spacecrafts well enough. So a lot of things to consider, but more to explore. And if Starship is an all-around, any planet, any moon vehicle, with the exception of gas giants, you can't land on a gas giant. It'll slip right through until you end up as like liquid hydrogen, metallic hydrogen. I don't know. I'm not a physicist, but it's pretty wild stuff. And if they build this new rocket, more power to them. They're doing what NASA had thought about in a similar way, but they're doing it now. They're doing it faster, cheaper. And when you see them test a rocket, it's like the Wild West of exploration. They're just doing it under a tent out in the open, and everyone gets to see it blow up. So a successful test, not successful mission for landing, but that's just one of the benchmarks, and the whole thing was a test, and it's a brand new rocket. So imagine, building a car out of base materials. That's where he's starting.
Yeah, definitely. So I kind of want to like backstep a little bit here and talk a little bit more about the life forms the potential life forms on these planets.
Okay.
What do you think the likelihood is that there might be life in our solar system on these liquid water moons and other bodies with such resources?
Okay. We look for life that is similar to our life. And with that, we use a lot of water, and here on Earth, you can have solid ice water.
Yeah.
You can have liquid water. You can have gaseous water, water vapor in our clouds. So we look for those similar environments as we explore, but maybe there's other life forms that don't use the same thing.
Yes.
Oxygen is a great molecule to throw electrons around, so it's possible. And first, we'll probably look for the signs of life that we use here on Earth. Could there be life somewhere else? There's a non-zero possibility. The Fermi Paradox puts this out pretty well, where are all the aliens? You tell me there's 14 billion years and nothing else had evolved in this time. How would that be possible? So it goes through a few different scenarios where, for example, the fishbowl method or fishbowl theory says that there are aliens out there. They're just leaving Earth alone until we build our own capabilities to explore space. Whereas some of the other theories say that there's not enough time for life to evolve in the same way that it did here. If Earth is 5 billion years old or 4 billion years old, and life evolved in the past or more recent, 3.5 billion years or whatever it is, what are the chances that life would start at a time where it would coincide with us?
Yeah.
And at a time
that's interesting that like you have that as the nuanced thing,
so
the theme, right?
Maybe there's life out there, but it's slime on a rock.
Yeah. Or maybe they did evolve just not the same way as us.
And their civilization already ended after a nuclear war. We don't know.
Yeah.
The answer is we don't know. But if we're looking for life, the universe is stocked with the ingredients that it needs. If you look at the most abundant reactive materials, they're out there. The same and available for any life that might want to use it. So we're looking, for us, but space is difficult to do anything with, especially if you can't breathe through it and can't get there very quickly.
No doubt. So obviously you have a way more informed opinion than I do on this sort of thing. I'm a tourist on the fringe.
Hey, we're all tourists
as
we spin around on this rock we call Earth.
I'll drink to that, brother. But I was going to ask, with the wealth of information that you have had access to, what is your opinion? Do you think it's more likely that, maybe there has been a civilization and nuclear war already knocked their entire thing out of existence? Or do you think it's more likely that we're going to find some microbes at the bottom of Europa or something?
I would love to find microbes out there. The panspermia theory says that maybe life came from somewhere else. Maybe life started here and got kicked off on some asteroid, and there's now life spread from Earth to other planets.
Yes, I heard that before.
There's different ways that life can occur. Maybe it came from like abiotic factors, like things that aren't living, which is even less likely, but it all sort of has to start somewhere because we're here.
Yeah.
So what are the chances? I'm not a betting person, but it's non-zero. So it's totally possible. Do we have proof? I'd love to see it.
Yeah, that's awesome. So if you if let's say in 10 years SpaceX's program gets really legit and they start taking calls for people to go out on like excursions on different planets or bodies out there, what would you like to go visit if you had the capabilities to do it?
Okay. In visiting any astro body that I could.
That's realistic
cool to,
in our solar system.
Take a tour all the way around, but
it's probably going to take a few years.
And it'll take a few years, a lot of tests. No one's volunteering to, jump on it right now. We're still building
I
the
think
thing.
a lot of people jumped on that Mars mission, actually.
They'd love to see it happen successfully, but this is still pretty early in the stages.
Yeah, no doubt.
So what we have is development.
Mm-hmm.
And everybody wants to see development happen faster and for less money. And so it's sort of a balance. So it's, beyond me that anybody can start a rocket company and start launching things. There was a rocket test earlier today. I think it got scrubbed to another date, Astra. I'll have to check up on that. But basically, it's a new rocket company. Is that a
space set? Oh, it's a new rocket company.
New rocket company, yeah.
Astra.
Yeah.
Interesting.
And I think it's Rocket 3.2 or whatever that is. So a new company, new rocket, totally new thing. It's literally similar. It's similar to the Wild West approach of, can we do it? Let's try.
Yeah.
And that's awesome. Now, if I could jump on a rocket that works and will bring me back safely, because I'd love to come home. My wife doesn't really want to leave Earth
You've had this
to go anywhere else.
Length.
Yeah, but it'd be cool to see Saturn up close, but I wouldn't want to go there anytime soon. Because it's like, I don't even know, 5 years to get there, depending on how fuel efficient you make it. If you watch a TV show, The Expanse, is
that on Netflix?
I'm not sure what it's on, but basically they have a drive with unlimited power, and anytime you go somewhere, you have to speed up to get out away from Earth to hit escape velocity, so you got to be going pretty quick. But then, whenever you get to where you're going, you got to slow down, and it takes fuel for both parts. So if you got to bring all that with you, it makes it real difficult. So a 3-day out, 3-day back, night or two stay on the moon would be awesome. I'd love a spring break on the moon under some pressurized dome, slap on
kind of
an
like
EVA
Futurama
suit.
had.
Oh, I don't know.
Oh, you never watched Futurama?
I watched bits and pieces. I didn't really get into
they have
too much.
They have like a dome theme park on the moon. So
if we
like
go to the moon, if we go to
attraction.
Mars. Oh, cool.
Yeah,
if we go to the moon, if we go to Mars, chances are the first bases will be built underground. They might have like domes built in craters or artificially, and then cover it in monolith.
Why?
The moon doesn't have a dynamo effect. That magnetic field that the Earth has that we're protected with isn't available.
So it doesn't have an atmosphere.
Not really, no.
Yeah.
It has an atmosphere. It's just frozen things on the ground, pretty much. There's a wave of hydrogen, I think, going around the moon. It's kind of weird, but the moon doesn't have anything to protect from that solar radiation. So when we see auroras here on Earth, we're seeing solar particles blast away from the sun and make it all the way out here to Earth, slap the magnetosphere out beyond Earth, and that tail of particles reconnects with more energy, and as it reconnects, it goes out towards the poles, following that magnetic line, and smashes the poles, making the auroras. Well, imagine that energy that it takes to do that, but without any protection from a magnetosphere, and you're getting it direct. Astronauts aboard the space station say that they see photons zipping through. Basically, you get little packets of energy that excite one of your neurons, or whatever it is at the back of your eye that detects light. And this energy is hitting the back of their eye with their eyes closed inside their room on the space station with all the shielding they have. So
that's scary.
To give you an idea of
I feel like that would be a crazy nightmare to have with those factors.
Yeah, I haven't seen it myself. You can withstand a certain amount of radiation, but you definitely don't want, long-term high duration or high occurrence of it.
Yeah. So with now that we're on the topic of, things that are dangerous to humans, what are some of the scarier things in space? I remember watching a documentary where they mentioned the existence of these things called gamma ray bursts.
Okay.
And I remember having a nightmare that night thinking, oh my goodness, this is something that's capable of wiping out the planet. But what are some things that you might be concerned about?
Well, a gamma ray burst isn't what I'd be primarily concerned with. I believe that they're more rare, When they happen, I don't think they happen in all directions. I'll have to check up on that. But we don't see a whole lot of gamma ray bursts
in this area,
like we don't get hit as much. The things to be worried about are, is my spaceship intact and can it bring me back?
Yeah. Right now,
all your food needs to come with you. All your air, all your water needs to come with you. You need to process all of this stuff. We're growing food on the space station right now. You need to bring some stuff with you, but whatever you're bringing is in a closed system. You're in space, nothing else around you, and you have the materials that you bring with you. So there's lots of scary stuff out there that I would worry about first before some gamma ray burst. But if the Earth gets hit with a giant gamma ray burst, it could sear half of the planet and heat up the other half enough to ruin all life. But that's not what happens, or not what we have observed on any scale.
What about the factor of the asteroids and things like that are out there? Do you think that's more of a likely thing for us to be concerned about on the planet? There
are asteroids that get drawn to the Earth every day. There are, meteoroids just float around in space. It's an asteroid or meteoroid up until it starts burning up. I'm not 100% sure. I'll have to look into this a little more to give you a better answer. But I think it has to do with the orbits, how close they are to Earth, so for example, between Mars and Jupiter is the asteroid belt, and they're in a solar orbit. They go all the way around the sun. Here on Earth, they're close enough to where they're getting pulled in by Earth's gravity, or they're just on a collision course. So any meteoroid that gets pulled in starts burning up with the friction and pressure in the atmosphere. Not ablative, adiabatic. There's a bunch of cool physics terms.
I was going to say, man, you're losing me.
I'm a Wikipedia warrior. I just go down these rabbit holes and learn as much as I can.
No doubt.
So when it starts burning up, that's your meteor. That's the burning up shooting star. You see streak across your sky. And then when it hits the ground, it's a meteorite. So
like whatever's left.
Yeah, if it reaches the ground at all. A lot of times it burns up and turns into dust and is scattered in the atmosphere, becomes particles with rain and rains down. Earth takes on tons of this dust every day, not just from stuff burning in the atmosphere, but stuff just floating around in space too. But, especially with meteor showers, you're looking at tails of comets, which after they shed everything in that tail, then you just have an asteroid that was a comet. And so we're basically on collision courses with the tails of these comets and taking that on, and that makes our meteor shower. So it happens all the time. There are asteroids out there. We track things big enough to worry about if we can catch them. The question is, can we catch them, and what about the ones that are just under our ability to see? Asteroids are as bright as a parking lot, the asphalt in a parking lot. It's pretty dim stuff. We only see them if the sun is lighting them up or if they block something out.
So what do you think the percentage is of what we're able to see out there as far as life-threatening bodies?
I would love to have a number for you, but I really don't. The early solar system was rock'em sock'em, asteroids everywhere.
No doubt.
Earth may have gotten a whole it's such a mess of asteroids. And we think about asteroids in the asteroid belt. They're everywhere. They're just mostly there's a high concentration in the asteroid belt and the Kuiper belt beyond. We're on the inner solar system, so we have things settled pretty well, but stuff from the outer solar system could come in. Stuff from the asteroid belts could be kicked off in a direction, or if it passes Earth, if it's a near Earth asteroid, minor changes, maybe the moon pulled it a little bit, and the next time it comes around may be different. These things are possible. It's a non-zero chance, and we live with that knowledge. And these asteroids, maybe they could burn up on the way in. There's not a whole lot we could do for certain scales of asteroids. So knowing in advance is the name of the game, and it's trying to know.
Do you think like as a species we are taking a responsible amount of precaution in this respect to monitor?
a bunch of smart astronomers and astrophysicists are worrying about it. Is the general public? No, they look to the experts,
of course,
astronomers, astrophysicists. I'm not an expert at all, but I'll take their opinion before I guess.
Yeah.
Yeah.
But I'm saying with your, you have a more informed opinion than I do. So what do you think? Do you think in your opinion that we're giving enough thought to it?
Absolutely not. So one of the things I say, and I say this a lot, the further you look into space, the smaller all the problems on the ground. If you have a giant asteroid inbound, that's a lot more to worry about than, did I collect all my receipts for taxes? So there are bigger things to worry about. I think getting along on Earth is important. Mm-hmm. Whatever your problems are, whatever people disagree about, we can work our problems out and then go on to solve really cool things. Instead, we end up focusing too much on, better missiles, which ironically led to the whole rocket program to begin with. So, to me, there's more to do, and everything else is sort of hindering the progress of space. Because the more research and technology we develop for space, we're also using it here on Earth too. Mm-hmm. And it's not just, cell phones or a more comfortable pillow or whatever it is. It's systems of technology, and we don't know what those are until we discover them. Just the other day, it was confirmed that there's a third elementary particle or elementary category of particles. So fermions, basically protons, neutrons, electrons, those things. Then there are, and those are made of quarks.
Yes.
Then you have bosons. They could base, so to my understanding, again, I'm not an expert. Mm-hmm. I'm reading through, trying to understand it.
What is your expertise, if anyone was curious?
Well, let me just there's fermions, bosons, and anyons. Basically, they exist in different fields. They interact differently. They're made of different primary particles. Maybe we were thinking about things not including the whole picture. So add that third dimension, and the whole story changes. So there are things being discovered all the time. Are we giving it enough attention? Absolutely not. I would love to read about that in mainstream news. It would make it so much easier for me to find this information.
Yeah, and I feel like it would be more casual talk for you to have with people if it was something that was mainstream, and we might all be more concerned about these things.
I get that Taylor Swift is a talented character out there, and I love that they're doing things that make people happy, feel good, sounds good, wonderful. But I also would love development in the space program and more talk about that. I'm no expert, but I'm a huge fan of exploring space, exploring our space, outer space, inner space. So let's solve our problems here on Earth and do big, good things. And after that, the universe is our oyster up until we find out there are aliens gatekeeping the next star.
For sure. So what is your expertise, if someone was curious?
So I do have a degree in biology, in genetics and developmental bio. And I started working in a planetarium, and really that's where I just fell down Wikipedia rabbit holes and learning everything that, NASA in the U.S., JAXA for Japan, ESA for Europe, Roscosmos for Russia. They're all doing different space things, and I started learning about that. So I have no official training in space, except for things I've learned at the planetarium and things I've learned from the experts I've interacted with.
And you were the one running of course, the Berks Astronomy Club.
Berks County Amateur Astronomical Society, brings in a whole lot of talented people. From amateur astronomers like myself, but they're going out with their telescopes whenever they can, looking at things, submitting data to NASA, and getting it approved and certified and put in with the whole data set.
That's awesome.
All the way up.
And you're the one that led that, the club.
Well, we also have university professors as well who have given talks. Some are available on our YouTube channel.
That's awesome.
But the Berks County Amateur Astronomical Society has been around since. I don't know, the 60s, 70s. A couple of people with telescopes in Berks County put it together, but it just built, and I can't take credit for what it has done, just because there's so many people with so much passion that it really shows, and it's so great to be a part of it. But right
so
now,
how long were you working at the planetarium, and then how long were you a part of the astronomy coalition? Is it maybe?
So I started at the planetarium. I walked in one day. He said, "Are you with the school group?" And I said, "No." He said, "Come back, please." I said, "Okay." But what's a planetarium? And he's like, "We'll talk about that." Cool. So I come back and we start talking about what a planetarium is. And I had no idea. I just said, "What's this funny looking building and why?" And he said, "Planetariums go over space. They explain space to, and this is an abbreviated version, they explain space and space things to school groups, different groups, and they do field trips, different tours, things like that." But by the time he's going through all of this stuff and showing me like everything that they do, and I just sort of fell in love in that moment with the whole idea of learning as much as I can about space. And at that point, he explained this stuff between, maybe it was a 2-hour explanation, and by that time he said, "Well, we have a 4:00 show coming up. Do you want to stick around
for
the show?" And so I ended up staying for the show, saw my first planetarium show there at the NEAG Planetarium at the Reading Public Museum. It was awesome. And then he said, "Well, glad you enjoyed it. Glad you like what you see here. The last guy just left. Do you want to work here?" And I said yes. So it was really awesome to jump into the NEAG Planetarium at the Reading Public Museum. Shout out to them. They do an awesome job. And it's really awesome what they do there.
I had been to an exhibit that you had led. I can't remember exactly what it was. I'm pretty sure Neil deGrasse Tyson was the narrator of the video. Sure. And then there was parts in between where you were pointing things out to us, and like, it was awesome. It was a giant projector on the ceiling, and you were kind of like, X, Y, and Z, these things that Brad doesn't know.
If you were anything like me when I walked in back in, I think it was 2011.
Oh, man.
A planetarium represents the night sky. It makes it real easy if you have a really high definition computer system, putting everything out there as if you were looking at the sky itself. So get to your local planetariums. Definitely check them out. I love them. And they're not just limited to space content. It's also awesome stuff, too. They do music shows. They do like historical presentations and things like that.
I remember
really, really
I actually went to a Smash Brothers tournament that was at that planetarium before. I don't know if you were aware of that.
Lots
that
of cool stuff that goes on there.
Yeah.
So definitely check that out. The planetarium is an experience everyone should have. So I started there in 2011. I was there 8 years. And with the Berks Astronomy Club, so it's the Berks County Amateur Astronomical Society, which is a mouthful. So moving forward, I'll just say Berks Astronomy to refer to the Berks County Amateur Astronomical Society.
And the hashtags over here.
Awesome. So with Berks Astronomy, I was aware of what they were doing. I never had the chance to meet them. Each time I wanted to, I was wrapped up with something else to do. I was a college kid, just too many things going on, but I would have loved to get there earlier. And walked into a few meetings, I think in 2018, and then they were doing their voting for officer positions and involvement with the club. And they said, "Well, do you want to do anything?" And I said, "I have no experience. I have no idea what I'm doing." And they said, "That gives you a fresh look. How about you?" And so 2019,
that gives you a fresh look.
Something like that, to that effect.
That's awesome.
Yeah, so 2019, I became the president of the Berks County Amateur Astronomical Society. We are a 501c3 nonprofit that just loves to share our love of space. We do scout groups, outdoor observing, educational presentations, you name it, pretty much. I spent the summer of 2018 going to different libraries, just talking about how we get to space, talking about rockets, telescopes, and that we're in space right now.
That's
as we
awesome.
Spin around on this ball of rock, 8,000 miles of rock beneath you.
That's crazy. So let me ask you this. Who do you think has the most advanced space program of all the countries that you mentioned?
The most advanced space program? We're all sort of working on different things, and we all come to the similar systems. So like an X-ray telescope, we have them, Europe has them, bunch of people work on those materials and fix them. I would love to say NASA, but I'm not on the cutting edge. I'm sort of a spectator, just like you. We can look at NASA, see what they're doing, contact people on the inside. So governments, and typically these things are really expensive to do.
No doubt.
Governments are the only ones footing the bill for it up until the commercial space race. So there were companies that were contracted by NASA to do things in the past. They've gotten more and more responsibility now. So then you have companies like SpaceX and Blue Origin who are building the whole rocket systems in their facilities with the help of NASA and the NASA intelligence they have. But I would probably say it's NASA. China has a great space program. India barely had a space program. I think they started in the early 2000s, and they've made leaps and bounds of progress. They actually have a launch coming up in a couple days. So it's always exciting to see, like the Indian Space Research Organization, ISRO, go through all of the steps that we did in a much shorter time period with a much smaller budget.
Yeah.
And they haven't flown astronauts yet. They're actually looking to human certify some of their new vehicles. So who has the best one? Maybe it's NASA, but I'd love to see more. So I can't get enough.
Yeah, no doubt. So if you, what's your opinion on the commercial space race stuff, right? Do you think it should be more government organized, or do you like the idea that there are actual businesses putting capital toward making space more accessible to you and I one day?
So the commercial space race ultimately would make it more accessible for you and I. That comes with a price tag, but the price is going to fall somewhere, and it's not going to be cheap. Think of it this way. The Crown Victoria was the taxi cab car, and Yellow Cab or whatever taxi company would run these Crown Victorias or whatever the older models were. But you have a car company making the car, and then some other company slaps their name on the side and rolls it around. For NASA to have built all of the systems that they did, like the shuttle, and they contracted all of that out as well, a lot of it. But now you have a company like SpaceX who's building the rocket, and NASA's slapping their name on the side. It's not that clear yet, but think of all the different types of cars there are. How cool would it be if that many types of rockets could bring you to the moon for a spring break?
That would be cool, I think, because then you could argue, the SpaceX 3000 Falcon Heavy was way cooler than the Chinese thing, or whatever.
Yeah, or who has a cooler ride, what the rocket's capable of.
This one has DVD players on the back of the seats.
Yeah, I think Virgin Orbit, you don't have to bring your phone because they have cameras all around, and you can use those, and it's a space plane. It just goes up and down. It won't get you to the space station, but it'll come down and land like a plane.
Interesting. That's a Virgin Galactic?
Virgin Galactic.
Interesting. So do you think which commercial company do you think is the furthest along on their developments?
Hands down, SpaceX.
Yeah?
Well, hang on. So Blue Origin is the company from Jeff Bezos, CEO of Amazon, where they're very secretive about what they do. And it looked like at the beginning, Blue Origin had just sort of rolled up all these small companies and absorbed them. And you get a whole lot of
small space companies, or just
small space companies. Yeah, whether they're manufacturing the steel or doing like super cool rocket stuff. I don't know.
Yeah, whatever it might be. Yeah, they have good gyroscopes over here.
Yeah, the gyroscopes, good example. Like the reaction wheels for NASA, we found out the steel that was used in those is not what we had thought for a certain number of satellites that we used. So there's a company responsible for the shortcomings of reaction wheels and things like the Kepler Space Telescope and other dead spacecraft. So which company's best or furthest along? Right now, it looks like SpaceX because they are the only private company to fly to the International Space Station with astronauts. Boeing had a chance. The test didn't go through as it was planned. It was a successful test, but a few missions along the way were not accomplished. So Boeing has a little work to do. the Chinese had their own space station. There's a few different reasons. I think the Chinese space program is tied to their military, so NASA won't work with them. It's a whole lot of politics involved.
Makes sense.
Things like that. We've been working with Russia, since the Cold War. At the time where we were fighting on the ground, they were making peace in space. So there's a lot of fascinating history to it and a lot to learn. But moving forward, I think the commercial space race is the way to drive the price down and get the access up. So right now, SpaceX is in the lead as a private company. And you can't buy stock or anything like that in them. But SpaceX is, at least a jump and a skip ahead of a few other companies.
I remember, I believe, maybe correct me if I'm wrong, I think it was in 2018, the Falcon Heavy launch was a success, and they got it into orbit, right?
It was February 18th or something like that.
You know it on the dot.
2018.
Yeah.
Where they strapped 3 Falcon 9 boosters together. So the Falcon 9 rocket from SpaceX has 9 Merlin engines on the bottom.
Mm-hmm.
It's a good engine. It's a good rocket. 9 motors on the bottom. And if you strap 3 together, you call it Falcon Heavy.
Mm-hmm.
So the payload at the very top of the rocket, the little Hershey kiss wherever a capsule would be, or the fairings, the 2 clamshell halves that come together, they launched we knew it was going to be Elon Musk's car. We didn't expect to see the spaceman in it, or at least I didn't.
Yeah.
I knew it was going to be the car, but if you wanted to grab attention, Musk knew the way, and so he launched his car into space. And most test payloads are like blocks of concrete. Not a whole lot of companies
because
will pay
they need
for
a
you to
weight.
bring their,
They need a certain weight, right?
Yeah, they need to prove that they can lift a certain amount. And so you can lift a giant block of concrete. You can try to get a company to pay for the hundreds and thousands and millions of dollars it takes to build a satellite, or you launch a car. So Musk went for the car and turned a bunch of heads doing it, because there is still a Tesla Model Roadster in a solar out to Mars orbit.
Yeah, that's so cool. I remember actually shed a tear when it made it to orbit, and it not because of the car or anything, but just I remember I was in a big group chat and we were all kind of going at it, and I remember watching it succeed, and I was just like, man, it's so fascinating what humans are capable of when we really work together. We can achieve these incredible engineering feats. It's a work of art, to come together to make something so extraordinary. I remember
that's the feeling that everyone needs to have.
I agree
about this stuff. It's really awesome. Seeing this take off, the shuttle program ended in 2011?
Yeah.
And we only got humans back on a spaceship earlier this year, 2020. So it was DM-1, the demonstration mission 1 from SpaceX, in their Dragon capsule. So for 8 and some years, 8 and some months, anyway, whatever the math works out to be, we weren't launching astronauts from U.S. soil. We were working with Russia to launch with their Soyuz capsule on their, I forget the name of their rocket. Dnieper? No, that's a different rocket.
I wouldn't know, bro. You're looking at me
so
like,
much. I'm looking for the answer in the reflection of your eye. So a lot of cool stuff out there, and boy, was it fascinating to see them launch this giant rocket and then see them, huck a car into orbit.
Yeah.
And then you have a car floating with a little spacesuit mock-up inside of it. It was really awesome to see. I'd love to see a small sat company like Rocket Lab from New Zealand, even though they're working with NASA under the NASA umbrella. They can only launch something like 500 pounds. No people. It's a small sat launcher. So with the Electron that Rocket Lab has, they could easily huck a CubeSat, basically a small satellite, out to that same orbit and catch up with the Mars, the SpaceX Roadster.
Yeah.
I'd love to see some collaboration like that. But then last year we had, or was it this year? The years are running together.
Yeah. This was a
there
crazy
was
year.
an asteroid from another solar system that swung by the sun. There were 2 of them. And they were denoted by an I after them. So there was 1 I and 2 I. I think the first one was named Oumuamua, which means messenger in Hawaiian. What that means, I don't know. There were some funky things about it. It was long, barrel-shaped.
The object?
Yeah, the object. Probably red from being in interstellar space, and it swung around the sun, and on the way out, the outgassing, whatever got heated up on the surface, might have made it accelerate, but it was accelerating faster than we would have expected, so maybe it was aliens visiting. We won't know until we have a small sat launcher like Rocket Lab be quick to launch when they see it inbound, be able to put a payload together and get this thing out to catch up with, one of these things, because otherwise it leaves the solar system and we'll never see it again, and we'll never know what was on that. So more power to the small sat launchers, even the heavy launch vehicles. If you can huck something out there and get it fast enough to catch up with one of these interstellar asteroids, how cool would it be to know what it's made of, what the interior is like? We just had 2 missions this year of little samples taken from asteroids. The Japanese and European Space Agency, I think, worked to get samples from asteroid Ryugu, a near-Earth asteroid. Those samples just came back. And then earlier, I think 2019, maybe it was 2018, NASA launched to near-Earth asteroid Bennu and grabbed some samples, vacuumed them up, dustbuster into this little, what's the thing, Roomba. It looked like a Roomba.
Yeah.
And they put it in a little aeroshell with a heat shield on the bottom, and they chucked it back towards Earth, and it's on its way. We're only just now discovering what else is out there.
That's crazy. And these are commercial companies. These are
these are all
NASA,
run by government.
Okay. Just making
JAXA,
sure. Yeah.
NASA, ESA.
Cool. Man, it's crazy to think about.
But NASA also works with colleges to produce this stuff. So JPL, Jet Propulsion Laboratory, I think works with UC Berkeley. So there's a lot of relationships that get balled together, but ultimately NASA's in charge as far as the stuff we launch here from the United States.
Yeah. Man, it's crazy stuff to think about.
Awesome stuff.
So what do you think about these people who think the moon landing was a hoax? Like, what's your opinion on that? What do you think I remember listening to this talk with Neil deGrasse Tyson where he said that it would be way more difficult to fake the moon landing than actually pull it off. What's your take on that?
To the people that think the moon landing was a hoax.
Yeah.
If they say that it's a hoax and we have NASA data, and that's the data that NASA presents, then the burden of the evidence of the presentation of why would be on the person doubting it. I'm not 100% sure. Like, I don't have a high-powered laser to shine it onto the corner reflectors that were laid out at each of the 6 Apollo landing sites. I don't have that high-powered laser to bounce that light off and get those photons back and measure how far the moon is. But right after the missions, we had a much better idea of how far the moon was and how it wobbles and how it moves. All the fuel that was loaded onto these rockets, we can measure that. You can see the skin of the Saturn V where the condensation was forming all along it. It would be possible to fake. I get it. However, when the United States and Russia, their largest adversary at the time, were at war with each other, and when we completed a moon mission, they said congratulations. I'd be curious to know why they wouldn't deny it as well. So I don't have the data with me. I'd love to see any evidence that it was faked, but from all of the things that were there, we're starting to see that. There's a robot around the moon right now called the Lunar Reconnaissance Orbiter. It's got an 8-inch wide telescope lens, or mirror at the back, and it can take pictures from way closer to the moon than we are. And
so this is an object that's in orbit,
it's
not
in
on
orbit.
The
It's a lunar satellite.
Okay.
And from all of the landing sites, it has shadows of where things were. It has blanks from before things were there. So the Chang'e 5 spacecraft, which landed just 2 weeks ago, I think, at this point, the Chang'e 5 lunar lander and Rover landed in a spot that didn't have any shadows, and now there are shadows there. So, did we go? I would think so. I don't have anything saying that we didn't.
That's convincing.
Yeah, nothing too convincing. I know there are some photographs of things that, to me, it doesn't say that we didn't go to the moon. Right now, the evidence is pretty clear that we did, to me. But show me the evidence, show me the data, and I'll be happy to look through it. But innocent till proven guilty, or that's not even how it works. It's like
I like what you said moments ago, where the burden of proof is on the other people, because there already are well-documented things that are. I guess the NASA documentation from this is public accessible.
If you have a high-powered laser, you can shine it at the moon and get those photons back. I don't know how expensive it is, but I'd love to see it.
Yeah. So, what about the people who think the Earth is flat?
I wonder, why do they think the Earth is flat?
I haven't done enough research on the flat Earth theory myself.
Okay.
I can't say I'm convinced enough to.
It's a good thought experiment. So, if someone said the Earth is flat, what do you question as someone who's not obsessed with space like I am?
Yeah. And, so my thing is, you have to deny the existence of the other planets or something, because have you seen the meme where it's all the planets lined up and they're all spheres, and then Earth is just like a pizza box shaped thing, and then it says the caption is "Crazy how nature does that."
Yeah, it's I'm curious at why anyone would think the Earth is flat.
So I could be wrong, and anyone out there can comment and correct me, but I think the general idea that the Earth is flat and there's a dome over the Earth and there's like an ice wall at the edge.
Okay.
Why wouldn't you believe that if I gave you a bunch of evidence that it was true, based on what you know already?
There have been expeditions to Antarctica.
But there's no I remember having this conversation, and I guess there's no public, like, you can't just go. I don't know.
I think that there are places you can go. It would be really difficult, and they don't want you to die trying.
That's probably a good.
Like, you probably end up at one of their ports or whatever it is. It was recently the anniversary of a Russian expedition to the South Pole. So the Russians tried, I don't know how many years ago, to say that there's an ice wall that we can't get over or through. I would be interested to explore it, but I also don't want to go crawling through Antarctica to die in the middle and get frozen.
Probably pretty cold.
It would be cool to check out.
Yeah.
But if there's a dome above, amateur rocketeers can send cameras up and see the curve of the Earth. You see it flat as you start, and as they get higher and higher and higher, the curve gets greater and greater and greater.
Yeah.
Now, it's not my rocket, it's not my camera. I didn't make the thing, build, or design the experiment, but I can see that there's something to it.
Yeah,
hot air
the
balloons.
physics behind it backs it up.
Weather balloons that go up really, really high into different levels of the atmosphere. People strap cameras to those, and it goes all the way up. The balloon pops, and you see what you see.
Yeah.
And it's a curve.
Yeah. I know another example that I can speak to, because this is one of the reasons I never was convinced of the flat Earth theory thing, was in the military, artillery and sniper rifles that are long range, you need to calculate for gravity and the curvature of the Earth and the wind and all of these factors to make sure your shots are accurate. So that's
really interesting.
That's one of the things that made me go,
Well, if the military's doing it, maybe they know what they're doing.
Why would they tell me? Like, it's interesting to me that a theory like that could pop up despite so much knowledge and science behind real practical things that are everyday resources for people.
Yeah, I think it was this is going way back to thousands of years ago, 2,000 years ago maybe. Maybe it was around that time, maybe a little later, who knows. Somebody knows. I think it was Aristophanes or I'm going to say that wrong, Eratosthenes, something.
Oh man,
this one guy.
You win, whatever it is.
This one dude and a couple of his friends were like, hey, on that one day where the sun's overhead, let's take measurements. And they used wells or obelisks. And on the same day, at the same time, they measured the shadows coming off of these things they thought were level and square and identical. And the shadows were different at the two sites. So at that time, he used some geometry to say, hey, there's this much of an angle between the two places. There's this much distance between the two places. So if we round that whole thing out, we got a round ball. And he was like 90-some% close to what the actual circumference of the Earth was.
Because the Earth is not a perfect ball, right?
Well, if the Earth was a cue ball, it would actually be more rough than it is now. It's a geoid, yeah. But
I believe the word that Neil deGrasse Tyson uses, oblate spheroid, to describe it.
Okay,
because I believe
it's not a perfect sphere.
Yeah, exactly.
Yeah, but
it's like a little, like it looks like Grimace, but like not as drastic. But it's like fatter
like
at the bottom
potato.
Or something. It's like a lumpy potato.
The gravity profile of Earth is like a lumpy potato.
Yeah.
It's not perfect, but it's pretty close to ball shaped.
Mm-hmm.
You know, I if I saw it from far enough away that I could see the edge, whether it's flat or not, if I see the edge, I don't think I could say, hey, this part is a little flatter than that part.
Yeah.
No, it's pretty close to a sphere.
Interesting. So are there any experiments going on from any of these government agencies or private companies that really pique your interest and you're interested in seeing where they're going?
Yeah.
Can you be specific?
And I don't know all of the different studies and, you know, robots that we blasted off into space. There are a few. Right now there are, I believe, 3 robots on their way to Mars. They're going to land on Mars. Maybe it's February 18th for that. February 18th rings a bell. Maybe it's... So there are 3 robots on the way to Mars right now. We launched them back in early summer, and they'll get to Mars a few months later. So those are exciting. There's the Perseverance rover from NASA. That's the one we know. I think a couple other countries. I think China and one other country. I don't know if it's India. India has plans to go to Mars one day. I'm not sure if it's their probe. Shaky on the details. So it's cool to send another SUV-sized robot to Mars to do more experiments, load up a few samples, and try to return them to Earth eventually.
Yeah.
Maybe. We're working on that.
Yeah.
But more stuff. So Europa, that water moon around Jupiter with the icy crust and the salty warm oceans with thermal vents at the bottom. The Europa Clipper mission has been pushed back for a long, long time. But it's a mission that would go underneath the ice and, you know, roll around, explore the oceans underneath the ice there. That would be super cool to see. Right now, well, we talked about Cassini that dove into Saturn, sent down a lander to Titan, the Huygens probe to Titan. It would be cool to see more out of the Juno mission, the robot that we sent to Jupiter, which did not go as expected. It was supposed to be going in a much lower, faster orbit, but they played it safe and went higher after a few things happened. And the magnetosphere on Jupiter is wild and powerful.
I imagine.
Yeah, it turns around once every 10 hours. You know that? A day on Jupiter is 10 hours.
What?
Yeah.
So it's moving that fast?
The red spot zips
and it's
right across.
Huge.
It's huge.
Jupiter's the largest planet.
Yep.
How many Earths fit in a Jupiter?
1.3 million?
No way.
1.3 thousand million. See, it's a numbers thing. I don't memorize the numbers very well.
All right.
1.3 something or others.
Yeah. Close enough, I guess.
Yeah. Jupiter's big.
Yeah.
And
quite.
Juno is on its way there to... Well, it's there. It's going around Jupiter right now. And eventually it will dive into the red spot. Originally, I think the mission was only to last for 90 days. But just like Cassini, well, everything's still working. Let's keep going. Rather than use our dispatch maneuver and go down to crash into the gas giant to keep the moons, safe from litter, whether it's life litter or, actual space junk.
Yeah.
Which there's a lot of space junk out there.
That we put there.
Yeah. So the Juno mission is, bound to crash into the red spot eventually. So that's exciting to see. And you get so many cool pictures out of that robot. So Juno is a mission to look out for now. The Juno mission, the Perseverance mission. There's one on its way to the sun. It's swinging by Venus. It'll swing by Mercury. Parker Solar Probe launched last year, I believe. It was the fastest spacecraft humans have launched, and it's on the way to the sun. So
interesting.
Yeah, getting things down to Venus and Mercury is difficult.
No doubt.
Yeah, they're moving a lot faster in the inner solar system.
And aren't they super hot? I would imagine.
On the daytime side, super, super hot.
Yeah.
On the nighttime side, super, super cold.
Interesting.
But even though Venus is the second planet, it's the hottest planet because it has that thick atmosphere, the runaway greenhouse effect, where the clouds are so thick, the nighttime side is, hot enough to bake a few cookies. So yeah,
that's pretty crazy.
Whereas on Mercury, it's more like the moon, not much of an atmosphere. So the nighttime side is freezing, beyond freezing, and the daytime side is way beyond boiling. So more numbers to come with that. Yeah. If you want to look up the temperatures of the surface of Venus and Mercury on daytime and nighttime sides. So there's a lot of cool space missions out there. I don't know them all. I'm discovering them all. It's
there's a lot out there, and they're constantly putting out new ones, I'm sure.
Yeah, well,
declassifying
it's
ones.
Sort of like every time you read a news story about something in mainstream media, it's like putting the quarter in, turning the knob, and getting a gumball at the bottom. Yeah. Versus you look into this stuff and you realize there's all these gumballs on top. Yeah. And you just pop the top off, and it's like getting a whole bucket or going to some large department store and getting like that whole bag of the gum of those gumballs. So there's a whole lot of missions out there. A lot are in planning stages. Some are taking effect now. I think it's IceSat 2 that's measuring Antarctic ice and Arctic ice and how all that ice is changing. Super important to know and keep up with as our North Pole melts a little more. So some of the oldest ice in the north, around the North Pole or in the Arctic Circle, let's say, some of the oldest ice is disappearing. And, it's the old ice. It's been there a long time. And it seems to be disappearing faster and faster. So it's a sort of alarming rate. So interesting things to keep up with as we move forward to figure out what's going on here on Earth. Yeah. When you look into space, all the problems on the ground seem a little bit smaller.
Yeah. Let me ask, what are the problems with not having a sterile object touch these bodies? What if there are microbes on some of these things that we're taking to these planets, and maybe they evolve their own way to survive on those planets? Why is that a bad thing?
So there's the obvious science answer of we want to know what's there. We don't want to measure something we brought. Yeah. The Russians sent a probe to Venus, and they tried a few times. Every time it landed, something went wrong. It melted. The first one melted. The second one, the lens cap of the camera melted. The third one, it was supposed to drill down into the surface and test the soil, but the lens cap popped off perfectly this time, only to land right under where the drill was going down to. So a really expensive way to test what your lens was made out of. Yeah.
That's funny. So wait, so when they land on these planets and things, how are they transmitting the information of what they're getting back?
Radio.
Interesting.
Yeah, radio waves travel at the speed of light. So
interesting.
For example, the Chinese mission, the Chang'e 5 that went to the moon, sent back an unencoded signal. So if you had the capability to translate those microwave radiation waves into video, you can watch the lander land. You can watch the samples come back. Like they didn't hide any of it. So it's really awesome to see. And again, to the flat earthers or there is no space people, they're receiving signals from radio waves coming from exactly where they said it was going. So more to think about.
Yeah, and it's in plain text, so anyone can gather this. These radio waves. That's so interesting. Man, that is.
So there's a lot.
I want to ask like really specific questions about like the radio waves, but I don't know if you know.
I touched base with the Reading Radio Club.
Yeah.
Shout out to them. They do an awesome job. I know they just helped out some emergency response teams. Figure out their communications equipment, how to optimize it. They went through and checked it all and made sure that they had good working equipment. So shout out to the Reading Radio Club. They're really awesome.
Yeah.
But they would be the ones to answer your radio questions. We actually did a presentation with the president of the Reading Radio Club, Chris Schlegel, who went through a whole lot of radio astronomy things that I had no idea about.
That's cool.
He knows way more. Yeah. So like interference, things from the sun, things like
that.
Yeah, so
those are some things I have questions about.
I'd direct you to the Reading Radio
Club. Might have to have that man on the podcast.
Absolutely.
Super cool, man. So I'm going to just tighten this really quick.
Yeah, do your thing. But it's exciting to talk about space, learn about space. I'm no expert, but you can gather whatever resources you can, get to a library or, order a book. Be careful with what rabbit hole you dive down on Wikipedia. But these things are possible to learn about.
What if someone might question the legitimacy of some of the stuff that you found on Wikipedia? Because everyone can kind of edit that stuff, right?
Yeah. But when they start posting really obscure physics things that would be like when I was doing my genetics degree, I would look things up and get super specific answers to specific things. So when you jump down those rabbit holes of research, when you get to the cutting edge, you find things that really haven't been messed with too much. They're posted by the researchers. Yeah. And so it's possible that it can get messed up. It's good to, if it says something funny, look at where the source is. Try to back it up. One requirement of Wikipedia is every time they make a claim, they put up a little asterisk, citation needed. And so it tells you that this information has to be backed up. And while it is possible to mess with, Wikipedia is a really great resource to have. You just got to know what question to ask. And one of those entries to some of this knowledge is just, look up space on Wikipedia and hit space travel or space history, space flight history, any of that stuff, and just start clicking links down the rabbit hole, or look up anything that might be of interest. Like if you have a specific radio question, Wikipedia might say something about it.
For sure. Oh, I've used Wikipedia countless times. I'm just saying, like, for you,
and it's
something
not
I've used it for a lot of things is like even IT research, like stuff, firmware specific.
But
like,
if I'm reading about how asteroids enter the atmosphere, and it forms a pressure wave around it, but adiabatic cooling is the actual air ripping apart, and I don't know, a bunch of cool funky stuff. So I'm learning things. I'm not an expert, but Wikipedia is a great resource to have. NASA.gov. Can't express how thankful I am for NASA. Boy, do they know what they're doing. It looks like they know what they do. So, shout out to NASA. And ESA and JAXA and Roscosmos and ISRO and the Israeli Space Research Group.
Do those government agencies work together, like internationally? Like Absolutely. I feel like they must share a lot of the resources so that not everyone's doing twice the work, maybe just double checking the next guy or something and adding to it.
So yes and no. They work together.
I'm sure there's some private things, of course, especially like you mentioned with China for the military aspect.
So here in the U.S. we have what are called Itar Restrictions. I forget what it stands for, but basically it's information that you don't want some party to get to use for bad. So while you can, launch a rocket and get to Venus and send something down to the surface, you can also use that same technology for bad purposes, and you don't want that in the wrong hands.
Yeah.
So I totally understand why they would be, a little bit secretive of how they do certain things. That said, it's also, I think, sort of testament to any space company or research organization or government-run space program to go out and get a scoop of Mars and send it back. Who does it first? Because everybody wants to say me, but it still hasn't been done. So it's one of those things that's yet to be seen, and we'll have to see, how they work together. For some missions like the Ryugu mission with Japan, they worked with the European Space Agency, ESA. So, there is crossover, but it would always be cool to pool our resources and do more. However, it may be better to leave it to the open market style, where it's not just governments competing. Now it's actual companies. Yeah. Private companies.
Yeah. And the governments.
Yeah. And the government's help. So we'll see how that works. The commercial space program is pretty new.
Yeah.
And I think SpaceX has gotten a lot out of it. So I'm definitely keeping up with what they're doing.
Yeah, definitely. So do you think the people who, they put a call out, I remember after the Falcon Heavy launch, they put a call out there for volunteers to go to Mars on their mission,
right? Where
it would be the first manned mission there, and basically saying it was going to be a one-way ticket. A lot of I think thousands of requests came in. I was even thinking about throwing my hat in the ring for that one, but I remember having this conversation with someone where I feel like the demographic of people going have to be some of the most motivated people on the planet. So you're going to send these really motivated people who are very ambitious and, powerful in their skills to create a civilization on Mars where they're literally fighting against physics to survive on this rock. You know what I mean?
Mars is a frozen, rusty, toxic desert.
Yeah.
It's the worst
toxic
camping
in
trip.
What way?
It has perchlorates in the soil, which are not good for you.
Not good for plants
for
either?
You. I'm not sure about plants.
I'm trying to think because
fungi that can break down perchlorates so that they're not toxic to you.
Interesting.
But you can't go and take a scoop and start planting,
rubbing it on your skin and stuff or whatever.
Yeah, you can't start using that just right away. You have to make sure it's not toxic. So it's like the worst camping trip, to bring everything with you, be stuck indoors with these people who, you're all trying to do the same thing, but you're all also using finite resources that you bring with you.
Yeah.
So astronauts are tough. NASA astronauts, Russian astronauts, everyone's screened to such an extent for, cognitive abilities, not just how smart are they, but how do they deal with situations?
Yeah, do they work well under pressure? How well do they handle themselves in,
so
inclement
the early
weather
days
or
of
whatever?
NASA, they were using military test pilots. We're still using military test pilots because they keep cool, they keep calm. When things go awry, they find solutions. They have the stomach that can withstand it.
Yeah.
Now, I'm not one for roller coasters, so I'm not sure if I can do a crazy space mission. I'm not your ideal troubleshooting astronaut, but it would be super cool to grow stuff on the surface of Mars. Start a fungus colony there. Start growing corn on Mars. So, there are things that would be cool to do.
Yeah.
But they're hopefully going to send smart people that can get along, work together.
Yeah.
And it would be sad to see, a United States base on Mars versus the Russian base on Mars versus the Japanese base on Mars.
Yeah.
It would be sad to see us not pool our resources for some huge endeavor like that.
The Earth base, not the American base.
And right now, there's a Japanese astronaut aboard our International Space Station, but there has not been a Chinese astronaut on the International Space Station. Instead, they have Tiangong 2, which is the Chinese space station. So there are still some things to work out. Whatever the geopolitical scene is down here on Earth, we got to figure out something better. There was a documentary, or not a documentary, some movie just put out that has sort of a documentary theme to it. I forget what they called it.
What was it about?
But
I might have seen it.
So there was a news article that came out. The former chief of the Israeli space program said, yes, there are aliens, and all of the heads of
state. I think I shared that article with you.
All of the heads of state know that there are aliens.
What's your take on that?
I'd love to see the evidence.
Yeah.
I don't know. I'm not an expert, but
I feel like it was a little vague. The article was a little vague. I wish they had more information.
They said that there was a galactic federation.
I saw that as well.
And so with that, if you can organize enough life forms to have a galactic federation, and we can't get our act together here on Earth right now, what makes you think that we should be a part of it at all?
Yeah.
You know, like it would be cool for me, cool for you, but you know, if some clandestine party within humanity wants to take everyone over for their water or food resources or energy or whatever it is, then we're obviously going in the wrong direction. Right now, that's the trajectory we're on. But people like Elon Musk who say, I'd rather be a spacefaring civilization because that's more exciting than to not be a spacefaring civilization, I'd have to agree with him there.
Yeah.
So there are a few things we would disagree on, but ultimately we'd be working on the same team, and that is team people and team space and team exploration. So there's a lot of cool stuff out there. I just wish we could work together to achieve bigger, better things. Definitely.
So kind of touching on the Martian base kind of thing, with the requirement for people to survive the trip there, I think that the people that would end up there would be some of the smartest and genetically well-balanced people, because they, like you said, they'd need to be practically trained military pilots.
Space is tough.
Yeah. So I think that would be, I believe that, the first person born on Mars would be like the first Martian. And I feel like eventually they would evolve differently than humans and become maybe a stronger race, a different species on some timeline. What do you think about that? That's something that this is Brad's brain that I just been thinking about that. Like,
check out the big brain on Brad.
Yeah, I don't know how big it is, but it's. I think I want to hear your take on that.
The first Martians,
yes,
are part of the same race, and that is Homo sapiens sapiens. Mm-hmm. We are human. That's like end of story.
Yeah,
you can be anyone, anything. You could have Neanderthal and Denisovan DNA. You're still Homo sapiens sapiens. You are human. And that's the element that we all, as people, bring to the table. The people born on Mars, they'll be Martians. We're Earthlings, and it's not common to make that distinction right now.
Yeah.
But just think, there will be Martians one day. Now, how will those people be different? On the moon, the gravity is 1/6. On Mars, it's 2/6 or 1/3 or something like that. I think it's 1/3.
Yeah, I think you're right, because I remember reading about I was so into this at the time.
Mars is small.
Because they don't need the same propulsion to get off of Mars as they do to get out of the atmosphere on Earth.
Yeah, so that's one of the advantages of Starship. It can leave a place like Earth, which is the largest rocky planet right now here in our solar system. It can leave Earth, but it needs to fuel up, I think, 6 times with different Starship fuel deliveries of methane and oxygen to get to Mars. But once it's there, it could probably get back, but it would be better to top off, and they'll likely need to. And there's no fuel station there. There's no gas depot. You can't run to the corner store there. So in situ resource utilization means that they'll find a way to make methane there, and they'll do that. They'll figure it out. I have no doubts that humans are smart and capable enough to achieve some of these things. But the Martians that are born there ultimately won't have too much of a problem, I don't see. There's a little bit of a problem with conceiving in space. There are some mammalian experiments, I believe, from the International Space Station.
Do tell. I'm curious.
I can't recall everything about it.
Yeah, well, what do you remember?
So from biology...
this is something you have expertise in. So now I really want to pick your brain on it.
So from the biological side of things, there's a few things that happen during fertilization and then a few things that happen right after. And so
do you need gravity for it? Is that like one
gravity
of the things?
sounds like a good idea when you have Earth-based systems doing things. And if you're involving human lives, it's a good consideration to have. Now, if a smaller amount of gravity can achieve the same thing, more power to them. Go for it. I'd love to see it. But here on Earth, we have 1G pulling us down constantly. As soon as you're in a microgravity environment like the International Space Station, you get to float around. Then when you get to Mars 6 months later, hopefully you've been working out that whole time. You've kept your bones dense. You've kept your muscles strong.
That is a concern, right?
And then
Don't
you land,
they need to spend
they
a
work out for
specific
2 hours
amount
every
of time?
day.
Yeah.
Generally. But once you're on the ground of Mars, if it's a third the gravity, then you have the ability where the intervertebral discs in your spine get to expand a little more. They're used to being stretched out, or used to being compacted,
yeah.
and you stretch out when you sleep. You're actually a little bit taller in the morning than you are at night, even if it's just millimeters. But those intervertebral discs in your joint space will get to stretch out a little more on Mars with less gravity crunching them down. So Martians eventually might be a little taller. They might be able to return to Earth in the first few generations, maybe, probably. I don't know. We don't have the data. We don't have the evidence.
Yeah, we can only speculate.
I can imagine that Martians, after a few generations, will be taller, not because of genetics as much as the environment.
Yeah,
so here on Earth, if you start hiking up to the Himalayas and you want to go climb Mount Everest, you can't just go traipsy on up the mountain. You got to go spend an extended period of time at base camp, and that helps you start to add more blood cells to your blood.
You acclimate to the conditions. Yes,
right.
That
so
makes sense.
Martians will acclimate to the conditions there, but here on Earth, if you take a bunch of bunnies and you put them up at high altitude, their lungs will expand over a short period of time within their lifetime, and then you can take them back down, and their lungs will shrink back to whatever they were before, probably. Similarly, on Mars, I think the same would hold, but we have to do the experiments. We have to find out first. And if we have a self-sustaining presence on Mars or any other planet, it will be interesting to see how it works, why it works, and to run those experiments. So ultimately, it's experiments first. The experiments are, can we get rockets there? There's the rocket experiment. There's the payload experiments, like are we dealing with mice or are we growing radishes or what is it?
Yeah.
And then the human experiment, the astronauts themselves, each one are an experiment. And so on Mars, we don't have any data yet. So I'm so excited to find out. Yeah.
Do you think we'll know? Do you think we'll colonize Mars in our lifetime?
So colonize may not be the right word. To put a colony there is probably more descriptive, but do I think we'll do it? Yeah. In our lifetime, I hope so. It would be cool to see the systems that it takes, that it requires, all the technology, all the stuff that we need. Can we do it better? Can we do it to stay? Will we go back to the moon to stay? It's a lot easier to practice on a 3-day trip with the moon rather than 6 months out to Mars and 8 months back from Mars if you spend less than, 20 days there or something like that.
Yeah.
So it'd be a good idea to practice. The moon is here as a good testing ground. Mars is out there, and I'd love to see it. But if the decision was up to me, it would happen, much faster than the geopolitical scene that slows everything down, it seems.
Yeah. So there's, I kind of want to dip into a conversation on civilization types, right? Like we as humans now on Earth are a type 1 civilization, right? Where we have basically become a planetary species where we can communicate worldwide.
Okay, I'm not 100% familiar with what you're talking about, but if you explain through it.
I can't remember where.
Here we're using the resources of Earth.
And I could be wrong. Maybe we're type 2 because of that or something. I could be mixing my memory up on this. But once you're able to go across planets, that becomes type 2. And then after that, when you can traverse galaxies, that's like type 3, where you're a universal entity.
Wow. Yeah. So crossing galaxies would be really cool. I'd love to do it in my lifetime, but it takes a long time to travel. So we start measuring things in light speed when it comes to, even stars in our own Milky Way galaxy. You got to remember, our home star is the sun. That's home base. That's our address. Right, Earth is our apartment number. We're sort of looking at the zip code here.
Yeah.
So it would be cool to have the ability to travel like that. I think in the types of civilizations, I've heard it where you're harvesting energy from stars directly. Shout out to Freeman Dyson. It's his birthday here on December 15th. But basically, a Dyson Ring. Let me back up. A solar panel collects light from the sun and turns it into electrical energy that we can use after you store it in a battery.
Yes. Okay.
Now, what if you take these, and for example, the International Space Station, I don't know where that is. Is that over there? The International Space Station, top right.
I think
they have
it
some
would
solar
be
panels
right
up there.
above me, maybe.
I think that's the Dragon capsule. No? Anyway. Excuse me. So solar panels are one way we're harvesting energy pretty much from the energy source that is our star. Now, a Dyson Ring is basically a way to harvest energy directly from the sun, putting those solar panels all the way closer to the sun. Now, a Dyson Sphere would be to, I think... And this is all hypothetical. Obviously,
I think I know what you're talking about. I've heard things like this before. Go ahead.
Encapsulate the star in energy harvesting equipment like solar panels.
Like cover the sun with
Dyson
our
Sphere.
thing to suck it up.
To
essentially
take the energy off of it. But the sun is an open-phase nuclear reactor. It'll destroy anything we put near it right now. So, or it won't last too long.
Open-phase nuclear reactor.
Yeah,
That's the coolest way to say it.
Also, anniversary today, I think it was 2000, Chernobyl shut down.
Oh, man. Chernobyl. Did you watch that
reactor
or dramatization?
I did
not. It
not.
is very good. I think it was... it came out in 2019, right? It came
recently.
out. It was last year.
Recently.
It was last year. I'm pretty sure. I think it was the best work of film in a mini series that I've ever seen.
I mean, that's one thing where nuclear tech can do a whole lot, but we got to be responsible with it. We got to build new systems that are better than any other ones that we've ever built before.
Yeah.
And do it right. Don't prolong any updates, fixing it. What's the word I'm looking for? Don't prolong any maintenance.
Oh, yeah.
Because of, some senator or whatever it is. Or use better nuclear reactors with better fuels like thorium. Look that up on Wikipedia, thorium.
Yeah.
Basically, you're using lower temperatures, lower pressures, and if you use a liquid salt reactor, you can constantly add the fuel. It's not all the hullabaloo that it takes to run a modern nuclear reactor, modern as of 2020. So, one more thing with that. But nuclear tech, where were we even going? You were talking about Dyson spheres.
Yeah, just open-face nuclear reactor, and then we talked about you were saying
our
Chernobyl.
Star and all stars are open-face nuclear reactors.
Yeah.
Taking hydrogen, the simplest thing on your periodic table, and smashing them together to helium, smashing them together to, I think, carbon. So 6. You're taking 3. There's the whole cascade. That's another thing to look up on Wikipedia. Just the nuclear fusion. Not fission that we do here on Earth, breaking things apart, but the sun fusing things together, making heavier things at the core.
Can we do that on Earth?
No.
No. So we I feel like
not to my knowledge.
Yeah. What about maybe I'm thinking of this the wrong way, but I thought that's what the Large Hadron Collider did.
Nope.
No.
The Large Hadron Collider collides hadrons. Now, hadrons are elementary particles, and that's where my knowledge stops. I am not a quantum physicist. Atoms make up stuff.
Yeah.
A particle accelerator, like the Large Hadron Collider, speeds things up. So if you take a proton, a single one, you take a little helium, they occur in pairs of 2, but let's say you have one. You charge it up, and you put it in this racetrack, essentially, and there's a series of electromagnets all the way around that help to speed it up. And that's all it does. It speeds it up and speeds it up and speeds it up and speeds it up. Now, you can speed up a few of them in such a precise way that they will collide. So, Large Hadron Collider...
Do you speed them up this, like, you see what I mean? Are we going this way? Or is it are they all going the same way until they crash?
That's a question for someone who works at the Large Hadron Collider. But if you look up the, what's it called? Athena? There's this cathedral-sized, like basically camera that absorbs different levels of particles and energy states and things like that, and spin of whatever's coming out, all the quarks, or primordial particles of whatever it is. They're measuring that in these, smashing atoms apart. Yeah. So the Large Hadron Collider just speeds those things up. But I am not a physicist. Yeah. I'm no expert, but it's really interesting to learn about these sorts of things because we're just exploring our natural universe. It's what's around us, and we're not telling it any rules. We're learning the rules that are already there. Yeah. So it's fun to play around with that sort of stuff. And if we could use nuclear engines to go into space to do things more efficiently, more power to us. But right now, the only way to get off Earth is burning carbon
resources.
Chains. Yeah, carbon chains to fuel a rocket motor.
So are there ways to go to, what was the body that has the methane ocean again?
Titan, the largest moon around Saturn.
Yeah. So is it possible to get there and harvest that methane and bring it back to Earth?
Well, we could harvest it and bring it back.
But I'm saying, is it too volatile of a place, right? Like, I imagine Titan being a really difficult place to land it's an earthly vessel, right?
Not necessarily. The Huygens probe is still there. I don't know if it's still submitting data. It's a larger moon of Saturn, but it's, I think, larger than our moon. It's not as big as Mars, I don't think. I'll have to double check all the numbers. I don't have numbers memorized, but
I'm just curious, is there a way to propel off of it that won't emit heat to burn the methane and cause a volatile reaction?
I think the atmosphere there is full of like sulfur dioxides and things like that.
Oh man,
I'm not 100%
sounds caustic.
Sure. Yeah, sounds a little. You don't want to mix it in your milk and drink that. Yeah, so it would be a good idea not to waste the resources to burn anything. You need those three things. You need oxygen, you need fuel,
a fuel source,
and a spark. So, maybe I don't know if it'll pose a problem. Hopefully not. I don't think there's many oxygen. I don't know. That's a good question.
Yeah.
I wonder if Starship could set Titan on fire. Could it? I don't know. Titan's pretty cold. It's pretty far out there. Yeah. Saturn's 1 billion miles from the sun.
1 billion miles.
Roughly, give or take.
That's crazy. What do you think about the idea that you can, instead of moving forward through space, that you can bridge the gap between 2 points in space?
Wormhole.
Yes, precisely.
Or whatever it is, if you make space shrink in front of you and expand behind you, whatever drive that would be. I'd love to see it. Yeah, I'd love to see it. I know nothing about making it happen.
Do you have any ideas? Like, I'm sure you've pondered the idea before.
Not a clue.
No?
Not a clue.
Not a clue. Have you, not a clue.
Yeah, I know stuff here on Earth a little bit. I'm no expert.
Yeah, no doubt, no doubt.
I'd like to change the city flag of multiple places. I think flags should represent their people. But I think Earth needs a flag. And I think there is a proposal for an Earth flag.
Yeah.
But if we start planting Earth flags on Mars, the Martians might eventually get upset about that.
Yeah.
You should watch The Expanse. I would highly recommend it. Right before the end of season 1, maybe.
What is I just got into a show on Netflix that's about space. It's about exploring potential life forms on, hypothetical planets.
Oh, cool.
Have you seen it? Do
Nope.
you know what I'm talking about?
Not a clue.
Man, I can't remember what it's called. But essentially, they go into... One of the ones that I thought was interesting is basically there's these things that are... They're like living balloon parasites that will feed off of other things because the atmosphere on this hypothetical planet's light, so then they can deflate and fall on the other flying life forms. I'll have to show you.
It sounds really
It's
cool.
really cool, man.
You should ask the Reading Public Museum's NEAG Planetarium if they have anything about that. Because I believe they have a show called Exoplanets.
Interesting. Yeah.
They explore what would life forms look like. For example, let's say instead of the main sequence star that the sun is, let's say it's much smaller, much cooler and red, a red dwarf star. Maybe plants would absorb red, so that would make plants red.
I mean, hypothetically, right? The process of photosynthesis.
Or I guess they wouldn't absorb red. They would be red because they don't absorb that, but they absorb other kinds of light.
Yeah.
Sorry,
I'm just saying
the process of photosynthesis.
Yeah, you only require the ultraviolet rays. You don't need every band of light that the sun gives off.
You don't need every band of light. I don't think you can just do ultraviolet rays though.
But I'm saying if the red giant put that off as much as our sun does or something. I'm no expert, but I would imagine that, the process could be completed. But it's interesting what you were saying about if it would change the colors.
Yeah, the gravity would be a little bit different. Maybe it's not a water-based life form and they can exist elsewhere. I don't know. Tardigrades, for example, an Earth-based life form.
Yeah, the water bear.
The water bear goes around just sucking up water on little mossy places, and scientists took a bunch of those and threw them outside of the space station, and they all froze. They all stopped moving, but they brought them back down to Earth, and they just started sucking up water again. So life is resilient. We may not be able to tolerate such things as well. Most people can't jump into a freezing creek and live well enough to tell the tale.
Oh man, yeah.
Shout out to the Wim Hof method, I guess.
Yeah, the Reading, PA Wim Hof Club. If anyone out there is interested,
life forms will adapt to wherever they are. There are adaptions that are coded. There are adaptions that are and everything's coded ultimately with life. Genes are just a blueprint. Basically, they're instructions on building proteins. Genes code for proteins. That's it. How they come together and do the other stuff, let's call it magic for now. It's really cool how it all works.
It is interesting, yeah.
But, would other life forms use DNA? Are we following a panspermia model here in our solar system, or could it evolve entirely differently? Water seems like a good medium for things to be alive in. Not too hot, not too cold. We are in the Goldilocks zone for our star here on Earth. Mm-hmm. But there are other planets in Goldilocks zones around other stars.
Yeah.
So it'd be interesting to see what other life would look like. And what would we even look for when we start to explore what life is out there?
Yeah. In your opinion, do you think that there's other life forms in the Milky Way galaxy, not on Earth?
Not a clue.
I mean,
I would love to say.
What do you
I
think?
have no evidence.
No, yeah, but what's your opinion? You, in your heart of hearts,
my opinion is I would love to know what's actually out there. But long story short, I don't have any evidence.
Yeah, I got you. I think we have a comment here. I'm starting to think that there is an afterlife. I don't know who that is. M. Levi. And was that one of your guys?
I don't know.
Perhaps. Oh, wait. I know who that is. He was on.
I can't see it from here.
Yeah, it's all right. It's a commenter from a few episodes ago. But anyway.
Yeah, if you have any questions, I'll do my best to answer. But I'm no expert. I'm trying to change city flags. I'm trying to get giraffe steaks to be
getting what?
Giraffe steaks. So clean meat. Recently, there's this huge push for alternative sources of protein, and there are companies that try to design burgers that taste like the meats that you know.
Yeah. Beyond Burgers, for example.
There are companies. Now, why would they try to emulate beef when you can do something else? So the whole push for clean meat, it takes less fuel for it, so less food, less water. Instead of 7 years to raise a cow and butcher it, then you can spend, a year growing something in a petri dish, maybe less, just to get the same amount of mass. And you don't have all the byproducts. You don't have to have a pasture, anything like that. You just have a warming cabinet or whatever it is that it takes to grow. So clean meat is the idea that you're growing meat in a petri dish. You grab a couple muscle cells from whatever it is, and you grow them in a petri dish.
I've seen this before, yeah.
So if you can do it with cows, I want to know, can you do it with giraffe? And can I have a giraffe steak? Because it is entirely unethical to butcher a giraffe.
Why?
They are an endangered species.
Okay, fair enough.
There are fewer and fewer all the time.
Fair enough. Fair point.
But, yeah, entirely unethical.
I feel like an idiot for asking.
As much as I don't think I can walk around wearing giraffe leather and be comfortable.
Yeah.
That's a little...
or not be scrutinized anyway.
It's not my style. No, I think it would be interesting to, let the giraffes live, grab a couple muscle cells. They don't die. The animal doesn't die. The cells don't die. You grow them in a petri dish. You don't have to, have cow. It could be kangaroo tail. It could be giraffe. Mm-hmm. And so I'm all for clean meat giraffe steak.
Interesting.
And if we go to space, the pound for pound crop that makes the most sense that you can milk, like you can have different types of food sources from them. So milk with mammals instead of, are you going to bring a cow to space? That's a lot of room, and you're going to have to bring a lot of grass or hay or whatever it is, in addition to all the water, and then you have to deal with all their byproducts. Rather than bring a cow, I'd rather clean meat. But there was a study done, pound for pound, the best livestock, pound for pound, with turnaround generations, and you get milk from them.
Insects.
Any ideas? Well, insects would be a high source of protein, but there's some problems there.
Like what? I think that would be the thing to bring. The most efficient thing.
But for mammals, it's mice.
Mice. Interesting.
And I don't want mouse soup. I really don't.
But mouse steak, though.
I still don't want mouse steak. I get it. It's a delicacy in some places. It's not for me.
Yeah.
I would much rather grow giraffe steak on the International Space Station.
That's interesting. So mice are the fastest gestation period and everything.
Yeah, I saw something
to become
that
mature.
That mice would be the fastest generation, and you could get the most out of it.
I feel like, as far as mammals, right? Like maybe you're right with that one, but I feel like insects would be the move.
Maybe, I don't know.
Because like some insects mature in weeks,
And we got to find a way to survive in space, and ultimately, like, we got to figure out what systems can turn our excrement into a food source for our eventual food. We got to loop it all together. And right now, the International Space Station has the most efficient water processing system made by humans, turning yesterday's coffee into today's coffee.
Yeah. That's awesome. That's funny. So let me ask you this. Did you see the movie The Martian?
I did.
So I think that's probably my favorite space movie that I've ever seen, because
that's a good one.
I feel like it was the most realistic, and it had the most, in my opinion, and it's an uninformed opinion, as compared to someone like yourself, the most accurate portrayal of real-world physics and things like that. What's your opinion on that movie?
So, The Martian.
Yeah.
Excellent film. Shout out to Ridley Scott for the book and helping with the movie and everything. Wow. Except, well, let's start from... So, I don't think I would drive to, what was it? Spirit? He digs up a nuclear reactor and puts it in the passenger seat with him.
Yeah.
I don't think I'm that brave.
Yeah.
That's quite a move.
Yeah. Another thing, kind of touching on something you mentioned moments ago, the soil on Mars is contaminated.
Yeah, you can't just stir it with your poo.
And and make potatoes happen. Yeah.
Yeah, definitely. It would burn your throat. I don't know everything there is to know about perchlorates. I'm not a chemist. But I think you need to work on those.
And maybe something happened in the show or in the movie where he was a botanist or whatever.
Sure.
Maybe he was like, oh, I need to just,
treat it
take
with bacteria.
Yeah, exactly. Yeah.
Maybe
that happened and maybe you and I aren't recalling it.
Cut, ended up on the cutting room floor. But the whole premise of The Martian is where I have the problem with The Martian.
Humor me. I want to
starts
debate
off, they have
this
this
here.
spaceship.
Yeah.
And there's a dust storm coming.
Yeah.
Now, if there's a storm coming, what do?
You hunker down.
You hunker down. They blast it off, which is entirely like that's where things might go wrong in one of those situations. The dust on Mars, the air, is 1/100th of the thickness it is here. So Martian air, a dust storm on Mars, isn't going to blow anything over.
Oh, interesting.
The particles it has, very fine particles, you probably don't want to breathe that stuff in. But, the whole premise, it's not going to make an antenna snap. Spoilers for The Martian.
Yeah.
It's not going to... The whole premise of The Martian was off. But to make the story happen, you got to start somewhere. So I give it a pass on that, and the rest of it's phenomenal. But for the premise, it wasn't to the science.
Yeah.
I remember going to see Gravity, and I forget. I went to see
got
Gravity.
A lot of flack from people. I haven't seen that movie because I saw
George Clooney, Sandra Bullock.
Yeah.
At the beginning. So I went to the theater, and this was the first movie I went to see on my own.
Ever?
Yeah. I never went to the theater by myself, and it was at an hour and time, like they were about to take it out of theaters, and most people had seen it at that point.
Yeah,
they
so
were
you're like,
see
I got to see it.
There was like 2 other people in the theater. So I got the best seat. I got up close and personal with the IMAX screen. And boy, that was my best viewing experience, because the movie starts out silent and a view of the space station with the Earth in the background, similar to something like this.
Mm-hmm.
And it was exactly that. There wasn't music in the background. There wasn't chatter or in the beginning or narration, whatever. It was silent. And that is what space is like. There's a hum on the International Space Station. You got a bunch of systems whirring and making noise.
Yeah.
But it was silent to show you, like, there's no air in space to transmit a pressure wave of particles that are going to make your eardrum say, this is a sound. It was silent. So that was one of my best experiences. But then Sandra Bullock has a tear roll away and it shoots out towards the camera, which was a cool CGI effect. But it was totally not there. It was one of the many things wrong with that movie. Otherwise, it was pretty cool. The idea, the Chinese space station, the whole plot. Yeah. Spoilers. Also with The Martian, the uncapsuled launch. That was just hard to believe.
Yeah, I thought that was an interesting part of the movie.
One screw fall off, it cracks your helmet and you're done. And then you poke a little hole in your suit and you're losing air. I don't think you have enough to sustain it. And that was a little wild, but it's a movie. You got to suspend your disbelief. And I did just that and enjoyed it.
Yeah. What is your favorite space movie?
Men in Black.
All right, fair enough. How about your favorite where they try to make it as realistic as possible space movie?
Maybe it's Men in Black. I don't know.
This guy. That's funny.
Who knows?
What did you think of Interstellar? That one I had a lot of problems with.
Yeah, the whole time dilation thing, a wormhole hiding behind Saturn. That's where, you have to suspend the disbelief. Otherwise, great movie. The depiction on the black hole there was from actual data. Mostly, they made it look a little cooler, but it was, the best depiction of a black hole that we had to date, up until we started taking pictures of one. Yeah, and releasing the first.
And we did get those images. Yeah, that was crazy. I remember seeing that. But in Interstellar, the spoiler alert here, the movie opens where there's like a drone flying, and he's like, "Oh, let me go hack this drone that's in flight," and he hacks it and crashes it.
Sure.
No.
How realistic is that?
was.
It wouldn't happen that quickly.
There's no way.
But most of the Space Force are people working on computers, preventing
it's
satellites
a lot
from
of
being hacked.
Cybersecurity stuff for sure. But I worked in cybersecurity.
Okay.
So I was mad at that right out the gate. I was like, I hate this movie already.
It's like, fry the receiver on it.
Yeah. Well, no, dude. It's just like they're chasing it in a truck and just like trying to like hack while dude. I don't know. It started out rough for me with that, and I was like, oh man, this thing better be good because I hate it already.
But if you suspend the disbelief, then you can start to enjoy the movie. Interstellar, the whole conclusion of it was just beyond me.
Yeah, I didn't like the ending either. But one thing I thought was interesting was when they landed on that one planet, and when they got back, like how many years had already passed.
Time dilation, yeah.
Yeah, you didn't like that.
It's believable if you can hide a wormhole behind Saturn. That said, and if wormholes work, they work in math. They don't work, or we haven't seen any, or created any that I know about. If you can suspend your disbelief, it would work. However, it's just one of those things where I see it, I'm like, all right. I'll file it away. Don't react to that part because like you don't put the whole movie on a single item.
Yeah.
But it was all right.
I think it was interesting because didn't they go to a black hole first and then it became a wormhole or something like this?
Yeah.
I'm recalling it badly maybe, but yeah. I didn't
you
like...
You gotta suspend your disbelief.
Dude.
If you want to throw as many space things into a movie, I get it.
Yeah, but, I get it.
If you're looking at how space movies actually go, it's when are we running out of food?
Yeah. Well, that's what I liked about The Martian.
Yeah.
The Martian was another one that had like that one hit me in the feels. Like I almost shed a tear on that one.
If you're
once
interested in space movies or space operas, as they are,
space operas.
Yeah, Star Wars is a space opera.
Fair enough.
Or a space western. Well, I don't know what you want to call it. Yeah, basically. You should definitely get into watching The Expanse. You don't have to finish it, but just start it.
Yeah.
Because, wow. It sets up the universe a little bit forward from the time that we are in.
Is it your favorite work of film that's about space?
It's the one
Besides
most currently on
Black.
my palette because I saw it recently.
Yeah.
So I would highly recommend watching The Expanse because they don't break the physics. It's a part of the storytelling.
That's cool.
As long as you believe the things that they start putting in there.
Yeah.
Up to a point.
Yeah.
Without saying too much. So you should definitely watch The Expanse.
I will take your recommendation. I'll at least start it. And if I'm into it, I'll
finish
I'll
the first season.
Yeah. Finish the first season?
Yeah.
It's good. The first season's great.
Oh, it's great. If you like space enough a little, it's great.
Enough a little. That's awesome, man.
Yeah.
That's cool.
Yeah, are there any questions or anything?
Yeah, we have one. Is it possible to live on Titan?
If we bring everything we need to live there, yes.
Right, yeah, because Titan's the one that's oceans of methane.
Methane lakes. So it's sort of a yellowy-looking moon around Saturn. It's far away from the sun, so you need way more solar panels to get the same kind of energy that we get here on Earth from a solar panel.
Yeah.
I think like calculator solar panels are like something like 5% efficient. I don't know the actual numbers.
Yeah,
the most efficient solar panels now are somewhere around like 30%, which is still not
great,
efficient, really. But it's a step in the efficiency direction. To get the same amount out there, light works on the inverse square law. So the further out you go, the more solar panels you're going to need because that will dissipate.
Interesting.
Yeah, so it's not...
I didn't even think of that.
Yeah, so getting energy out there, that would be much more difficult. Of course, you have the methane to burn, but you got to burn it with oxygen. You got to isolate oxygen, bring it with. You probably have to refine all of this stuff, make sure there's no...
Are you
nothing
aware
in there that's gonna make your system explode? You gotta, what's the word? Strain it? I don't know.
Yeah, or contain it like properly.
But you need a heat source, and you're gonna be living indoors.
Yeah.
Yep.
What is there oxygen on Titan that's breathable?
I don't think there's just O2 as it is. Here on Earth, our air is mostly nitrogen.
Yeah,
70%? So it's inert, something like that. Early Earth was low oxygen, then it went to super oxygen. Now we're hanging out around 20-some% oxygen, like 21 or 22%. I don't know what exactly is in the atmosphere of Titan, but I know that you can't just take your helmet off. Yeah, so far as we know, there is no place that you can go other than Earth where you can just take your helmet off.
Is there oxygen that we can breathe on Mars, to your knowledge?
I mean, there's oxygen in all of these places, but it's locked away with something else. So carbon dioxide is a carbon and two oxygen. You'd need to get the carbon away from it, but it takes energy to rip that carbon away from it.
Yeah.
So we can, use the resources that are there, in situ resource utilization, or ISRU, ISRU, and we can start to make oxygen that we can use there. And it's better to make it with robots there before we send people and need it then. But you can, I don't know, break down rocks to do it, because rocks are like silicone oxides, sand, things like that. You can get oxygen from other things, but it's an energy-intensive process. So you got to get your energy from somewhere, whether you're setting up a nuclear power plant like we've sent on some of these rovers these robots we've thrown at Mars. But we have to think about all of it as a camping trip where you bring everything you need with you, including the means to return with, unless you're using in situ resource utilization, if you're using the stuff that's there to make it. So if there's oxygen on Titan, chances are we have to refine it. We got to make sure we can use it. It's not riddled with anything we can't breathe. And probably balance it, because 100% oxygen is a dangerous thing to have when you have sparks and things like that. So
yeah. What do you think is the most resilient creature on planet Earth for space travel?
That's a great question.
Like, if I was like, let's say I was a malicious guy and I wanted to gather a vessel with some of the most resilient creatures on the planet because I want to colonize a body out there, despite like someone else researching to see what's there, and I just want to colonize it and make my own life forms happen on a place.
There are a few different sterilization processes that humans use to send stuff out, and a few different tiers. So there's probes that we, let's say, send up around Earth. You want a TV station. Yeah. And so you're just bouncing radio waves around. We sterilize that, but we sterilize it to like maybe 10 million microbes in a certain area. It's impossible to sterilize it 100%. So you take it up to a certain level. If this thing isn't going to interact with anything and it's just going to burn back into the Earth's atmosphere, we don't need to sterilize it too much.
Do you know what the sterilization process is?
I don't 100% know.
What do you know? Because I didn't know any of that.
I don't know what they use to sterilize it.
And
we'll get to your question
radiation
in just a moment.
Or something.
I'm sure they use a series of things, but they're the cleanest places on Earth, probably. Yeah. So when we send things to orbit other planets, we are a little more careful. We don't want things to make the journey. So we sterilize it a little more. Now, if it touches down on the surface of a planet, we sterilize it even further. Yeah. So, for example, the Cassini spacecraft that went and orbited Saturn, took pictures of the moons around Saturn, was pretty sterile. Not the most sterile we could get it, but the Huygens probe that went down to Titan was much more sterile than the Cassini robot. That said, I think I saw something where there are two microbes that only exist in this place on Earth. Now, there's archaebacteria and eubacteria living around thermal vents in the ocean. Archaebacteria. Anyway, there are life forms that exist, extremophiles, that are around these warm thermal vents. Yes. Toxic environments. Like oxygen doesn't dissolve into water that low, so you don't find any fish in those areas. It's also full of like sulfur, whatever, pouring out of the Earth in these hot gaseous vents or whatever it is. So there are extreme life forms that could do it. That exist, but there are, I think, two microbes that are only discovered in clean room facilities at space launch centers.
Interesting.
So some super resilient something or other that can make it past whatever our sterilization processes are. So
that's funny
it's
they figure it out.
They kill everything else, and then something else pops up.
Yeah.
You can weed the garden, and then the disaster reconnaissance plants move in first. The clover, the dandelions, whatever. So however it works, we try to sterilize it. Now, what would you send? What would you want to send? Like,
let's say I wanted something that would thrive, right? So
sure, tardigrades are pretty resilient.
Yeah,
I would.
All they need is water, right?
They probably need more, but water is a good place to start.
Yeah.
If you're going to bring a life form to Mars, you want something that breaks down perchlorates and makes oxygen. So whatever fungus does that. Probably fungus, just because it's small and
I feel like it would need to be like a team of a fungus and a plant that work together, because fungi.
Plants are just the upscaled version of what fungus does.
Yeah, but fungi breathe oxygen and exhale CO2 like humans do.
I'm not 100% sure.
So I'm pretty sure.
Different combinations of moss and fungus and whatever breaks
I could
down.
be wrong on that, but I'm pretty sure that I'm right.
Yeah, we'll have to look that up. I don't know the answer off the top of my head.
Joe Rogan had a guy, I think Paul Stamets, he's the mushroom guy, but he was saying how mushrooms are closer to humans than they are to plants in a lot of ways.
Interesting.
Yeah.
Yeah, there's a whole lot to biology I do not know.
Yeah.
But it's vast, and if it's on the smaller side of functional, so genes and proteins and things like that. And then on the larger scale, superclusters.
I have no idea anything that you just described there.
So the smaller functional pieces of life are genes.
Yeah.
Right? So you know those genes
and
code
DNA.
for proteins. They're just blueprints to make proteins. Proteins stick together, build bigger stuff. Little protein machines. They're like tiny factories. And then, so here we're on Earth, the third planet going around our home star, the sun. All right? The sun is one star in our Milky Way galaxy. There are a couple billion stars in our Milky Way galaxy.
Yeah.
In this giant pinwheel spinning in space. The Milky Way galaxy is in the Virgo supercluster. So you sort of have to imagine strands of galaxies, sort of paths that they travel down. So if you imagine a spider web and it rains, the water's going to move down the web. So it's within that. If you have a really gross kitchen sponge with the porous material between and places where the fungus can exist, those are like where the galaxies can travel down. So one strand is a supercluster.
Yeah.
So we're in the Virgo supercluster on the Orion arm of the Milky Way. So around the third rock in our solar system, the sun. But then you have the structure of Laniakea. Now, Laniakea means endless heaven in Hawaiian. It's this porous structure where each strand is made of like bajillions of galaxies, whatever the number is.
Yeah.
I think we're estimated at over 1 trillion galaxies at this point. There's a lot of galaxies out there, and each galaxy has billions of stars. And in our galaxy, our sun has a few rocky places around it, one of which we live on, called Earth. So
I'll drink to that, brother.
Here, have some water. I'll raise it to it.
So
stay hydrated.
Yeah. What's your opinion on string theory? Are you familiar with it at all?
I'm a little bit familiar. String theory is part of a larger theory. I think Michio Kaku put it together. Or he was one of them.
I saw a video that he had put together that's on YouTube on it. Highly recommend. It's awesome. I've seen it a few times, actually.
So string theory, things are made of wiggling particles. Okay. Membrane theory is the next step beyond that, where you have a vibrating membrane. Let's say these membranes move past each other. This is quantum physics, and I don't know quantum physics. Super cool stuff. A lot of math. Definitely buckle down to learn it, because it's cool stuff.
Yeah. So one of the things he mentioned in that video that you're describing, too, is that there's a multiverse theory because of, like, with string theory, right? Because multiple galaxies can exist, multiple universes can exist, and that maybe I'm butchering this, but he said something to the effect of the Big Bang being the start of a universe, and that there might be a mute, and that these universes are like bubbles that pop in and out of existence and can kind of pair off, and that it might be possible for like what I was saying before about these like the civilization types where there could be universal transversing or traversing beings that could, let's say your universe, all the stars are dying in your universe, you need to go on to the next one to survive.
It'll be a long time before that happens.
Yeah, it's crazy to even try to think about this stuff, but conceptually it is interesting. Cool. Yeah.
I'm not an expert, I don't know, but it sounds like so the multiverse theory works in math. That's as far as I know.
Yeah.
We haven't observed other universes. Mm-hmm. We have our universe, the visible universe that you see, that you interact with, that we know.
Yeah.
Where everything we know and love exists. Now, other universes, do they work? Yeah. Do we have bridges to them? I have no idea. But if we're examining like elementary particles, the answers might be, in smashing these particles apart between, quarks, bosons, and any ions.
Yeah.
Or anyons, I think they're called. So it's new, it's cutting edge. I have no idea.
That's awesome, though. Do you think that humans can survive anywhere else besides Mars in our solar system?
If we're living indoors, if we can live anywhere. Venus would probably melt most things that we would want to use. It would be tough to get anything there to live on.
So you think... Obviously, Venus is the only other option besides going out. Well,
Venus
to colder
actually
places.
Isn't. If you want to live on the surface of Venus, that I don't see that working. If you have an airship, like a blimp floating in the atmosphere, since the atmosphere on Venus is so dense, you can float certain things, and it wouldn't be too difficult. And you can actually see some sunlight because the thickness of the atmosphere doesn't allow direct sunlight down to the surface of Venus. Every astrobody that we can stand on, I don't see why not. It's just a few might be more strategic, like practicing with the moon or Mars out of interest.
Yeah. So Mercury, is it in like a fixed stasis where there's always a cold side and always a hot side, or does it rotate?
It does rotate.
I think fast?
Its day is longer than its year. I'm not 100% on that. It's a numbers game, but it rotates very slowly and revolves pretty quickly. So the nighttime side on Mercury would be extremely cold, and the daytime side would be extremely hot.
Yeah.
So you probably wouldn't want to go there. But
well, I'm saying, what about in the middle? This is interesting because this is like that would be like the safe place, right? Because it would kind of be a mix.
Constantly running at sunset, I guess.
Yeah. Well, it's I guess I don't know. Interesting things to think about.
Sure.
Yeah.
No, it's a good thought experiment.
Yeah, no doubt.
Cool
exactly.
Stuff.
Thought experiment.
Yeah.
Where would you live?
Earth. Boy, do I love Earth. I'd love to visit the moon on spring break. Mars is interesting. I don't know if I have the stomach to be an astronaut, but it would be cool. But first we need the technology, and that's where the big push is.
What would you need to be confident that you could to go to Mars? Like what would a company, let's say SpaceX, say, Elan, we want you to go to Mars.
I would be comfortable going to Mars if my wife says I'm comfortable going to Mars. So that's how I get there.
Nice.
And it's not just to put it up to her. It's, like safety and peer review and everything like that.
Peer review? Yeah. For sure.
Yeah, just making sure the system works, make it work over and over. SpaceX right now has relaunched one of their Falcon 9 boosters twice, I think. So they're only starting to reuse this. I mean, imagine taking a plane from New York to Orlando and throwing the plane away and then boarding another plane and flying it all the way back and then throwing it away.
Sounds expensive.
We're starting to reuse these things, which has to be the way to go.
That's like the new cutting edge way that things are going.
It'll drive down the costs.
Yep. Exactly.
If you have more simple systems, like with the space shuttle, you had to pull off every tile and refurbish it and put it back together.
Mm-hmm.
that's just one part of it. And yeah, it's good to inspect every little part, but it's a time-intensive, refurbishable process. It's not reusable, it's refurbishable. And you're fixing it up every time.
Yeah.
So the shuttle was awesome. While we won't replace it, you know, it's a great vehicle to use if everything works correctly and is easy, but it's just way too expensive. So that ended the shuttle program.
All right, I got some comments I just want to check on.
Oh yeah, questions, comments.
We have a guy asking about the Fermi Paradox. If you could please just elaborate on. You mentioned it earlier, but I actually don't know what it is.
Fermi was a dude that said, where are all the aliens? And here's why. Here's a couple theories. One of them, maybe there were aliens a long time ago, and they all disappeared for whatever reason, whether it was disease or war or whatever it was. Maybe there are aliens way far away, but they can't contact us, and we can't contact them, because light only travels at a finite rate.
I'm remembering something about this now. Is this like the Ancient Aliens show?
No.
They talk about the Fermi Paradox at all?
Probably.
Yeah.
So the Fermi Paradox.
That's where I heard this before.
I wouldn't know because I don't watch Ancient Aliens, but the Fermi Paradox is basically, what are the theories for why we don't interact with aliens? Maybe they do exist. Maybe they're here and indistinguishable from humans.
Yeah.
And there's that.
Men in Black.
Maybe we're the aliens. Maybe it's you and I that are the intruders on this rock. The Fermi Paradox just explores where are
it's
all
Mark
the aliens.
Zuckerberg.
I'd expect more from an alien, maybe.
No, but go ahead. I'm sorry.
No, that's fine. The Fermi Paradox is worth a Google. There's some fun infographics on it, just detailing where it is, and it's a fun way for anybody to learn why don't we have aliens. The ingredients are everywhere. Maybe we are alone. You know, maybe just because we're a lonely species out here on Earth doesn't mean that there has to be something else.
Yeah.
You know, maybe we're a really lucky shot. Maybe not. Maybe the universe is teeming with life, and we're just looking for it wrong. Or it's stuck on a rock, and it can't. The space program on planet XYZ isn't going so well.
Yeah, for sure. The space program from the alien world. Yeah. Wasn't it because, to your point with radio waves traveling as fast as light, isn't it possible, or it is obviously possible, but I want to touch on like your opinion of this. What if there is an ancient civilization of aliens that was highly advanced and sent a message in our direction, and we just haven't received it yet because they're so far away?
What if?
Yeah.
Then it's inbound, and I guess we'll find out later. That said, and there's an awesome infographic about this. What would you do if you were the person that aliens contacted first? I know Neil deGrasse Tyson says, while you're on the spaceship getting abducted, grab something and bring it back so we can study it. It's a good idea. I think they might notice you stealing something, or read your mind saying it. Who knows? It's a good idea to know a little bit of math. So we're going to break out some geometry now.
Yeah.
Ready?
Shoot your shot.
You'd want a way to detail numbers, and aliens aren't going to recognize whatever you think it is. Maybe they have no idea how we work. So figure out how they communicate. If they see things, if they only hear things, if they only can use tactile senses to touch it, whatever the case may be, it's a good idea to know a little bit of math. So real quick, you remember what a right triangle is, right?
Of course.
Yeah, so a triangle has that 90 degree, a right triangle has 90 degrees on and one of the angles.
Yep.
And then you have side A, side B, and C is the hypotenuse.
C, yeah.
So there's a fun little handy triangle. Pythagoras was thrilled about it, I'm sure. It's a 3-4-5 triangle. So before you start detailing this, you can maybe draw one dot and put a 1 next to it. maybe 2 dots and put a 2 next to it, maybe 3 dots, put a 3 next to that, all the way up to 10. We're a base 10 species because of these things.
Yes. Yes. That's an interesting thing. And I remember someone saying in some country they use the knuckles and it's like 15 digits on one hand.
Could be.
Kind of thing.
It would make a lot more sense in the natural world, I think, to use 12 hexadecimal system.
Well, hex would be 15 as well. In coding, I'm thinking.
I don't know.
Hex is 0, 1, 2, 3, 4,
so
all the way to F. Yeah.
15?
It's up to 9 and then A, B, C, D, E, F. So it's 15.
Cool.
Yeah.
Yeah. So
and that's
for example, in the Martian,
a network thing. That's an IT thing.
It's computer stuff. I really don't know too much about it, but
why 12? Why 12?
If we had an extra finger, we could count to 12 on our fingers and toes. And so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, alpha, beta, and then 0. And so you're putting 2 more digits into the set. So rather than counting by 10s, we'd be counting by 12s or counting by something else. So you sort of want to establish that you are using base 10 math.
Yeah.
And that helps you sort of describe in math, because the math is sort of the language of the universe, if you will.
For sure.
And you can look at the gold record that Carl Sagan put together and how he described, well, it's this many oscillations of hydrogen ion, or this many distances of hydrogen ions. He's measuring it, but he's using math to describe things. So you want to show them that, you're not food, that you know something. There's a great infographic I'll have to dig up and send your way. I'm
interested in that.
Yeah.
And you're saying that by drawing these 3, 4, 5 triangles, you're describing to them that how would you get to 10 doing that, counting in threes? If you're describing it to the alien
counting
to show
in
that
threes?
You're drawing triangles with 3 sides, right?
Okay.
So how would you describe to them that
first you detail your number system. So let's say you got 1 rock, and then you got 2 rocks and 3 rocks and 4 rocks, 5 rocks, 6, up to 10, but then you put it aside as a set, and then you start adding another digit, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and 0's at the beginning, but 10 at the end has your 2 digits.
Yeah.
So that's where you're changing things for the next set. That would help to describe that you are using base 10. And then in the 3, 4, 5 setup of a triangle, it's just a handy little thing to know that if you have 3 on this side and 4 on this side, we know that this one's 5. It would be useful to draw a diagram of the solar system and circle the 3rd planet in the orbit around a star. And however you want to draw a star, maybe it's the 5-pointed easy one everybody knows. Maybe it's a round blip with a squiggly something.
Yeah.
And you point at that star in the middle of your solar system diagram, and then you point in the sky at the sun to let them know you know a little bit of something.
Yeah.
So
I feel like I'd be concerned in this situation, because what if they're like, oh, they know just enough to be really good slaves?
Yeah, well, that's one of the concerns.
Yeah.
Maybe there are aliens. This is exactly the way they want it.
Yeah.
More of Fermi's paradox.
Yeah.
The Fermi paradox. But good question. It's worth a Google.
Yeah, definitely.
And,
definitely.
A simple an infographic might be able to bring it up. I could bring it up, but I'll let you discover and explore.
Yeah.
Because that's what it's about. It's sharing my love of space, but also inspiring it as well.
For sure. What do you think about the theory that the pyramids were built with assistance from advanced technology?
I'd love to see any evidence.
Well, in Ancient Aliens, they have some evidence. I wish you had seen it. I guess maybe we can't talk about it because I don't have the evidence. They do. I can't vouch for them. I hadn't seen that.
We'll have to do like a watch party.
Yeah, I'm down. We'll do like a couple episodes of that, and then a couple episodes of your what was the show that you recommended?
The Expanse.
Expanse. We got another one here. Ooh, okay. This is a complex question from today's sponsor, Vedinian. Any thoughts on the potential phosphine found in the upper atmosphere of Venus?
Excellent question. Recent, apropos, you might say. Phosphine gas. So basically what we're asking about...
Is that like phosphor? Is phosphor in that?
3 carbons, I believe. And it's phosphine, I think. It's
yeah. That's how he spelled it. I pronounced it wrong.
It just tells you about the bond structure of what it is. So phosphates have your phosphorus and have your... I said carbon before, that was wrong. It's 3 phosphorus molecules. I think some hydrogen involved there. And so right now we see phosphine as a biosignature, letting us know that something's alive. It's not naturally occurring as much or in the quantities that we find in normal places. And so we see phosphine as a byproduct of, life. So if we notice this stuff forming in Venus's atmosphere...
How did we detect it? Do you know?
I think it had to do with looking at... maybe it was the sun, maybe it was a background star. And the light scattering through it lets us know what's in those clouds, so we can detect what chemicals are there. So phosphine, so far as we know, there are some processes that it could be manufactured at a small scale by natural processes, whether it's like ionizing radiation from the sun or other sorts of radiation or pressure and temperature. Maybe you could stew some up. Yeah. And so there's sort of a base level that we would expect to see, but we noticed that there was a lot more
than we normally would expect.
Yeah. And, maybe it's lightning through the atmosphere of Venus that's in this process that we didn't consider. I don't know the answer. Why do we see it? It can be a biosignature, but it doesn't mean it necessarily is. If we have some exploring to do, but it goes back to that phrase, and I forget where I heard it first, but if you hear hoof steps, if you hear galloping footsteps, think horses, not zebras. So, what's the simplest answer? Occam's razor. What's the simplest answer we can find here? And it's worth exploring. And just because we have one answer doesn't mean there aren't other potential answers too.
Yeah, that's interesting. Could be deer, right?
Maybe it's giraffe.
Yeah.
Who knows?
Giraffe steak. No, that's all. I want to make a T-shirt with that now.
Give me a giraffe steak, an ethical giraffe steak. Please don't murder giraffes.
Please don't murder giraffes. That's funny, man.
Giraffe leather is not worth it, man.
Yeah, no doubt. We gotta do it the right way.
Yeah.
Do you think there are alien life forms on Earth?
I'd love to know.
Maybe
we are the aliens.
Yeah, true. Has any evidence been shown to you that maybe would convince you? What is the most convincing theory that you've heard? Maybe that's a better question to ask.
I can't say yes and I can't say no because I don't have any evidence. Right now.
But what has been one of the more convincing things you've heard?
One of the things to consider is life uses genes, uses DNA. And if alien life uses DNA, then I'm sort of, up the creek with it. But maybe alien life forms wouldn't use DNA. Well, we haven't found anything that doesn't use DNA that's alive. And we'll include viruses in that one, just because they're using, that sugar phosphate backbone and a few chemicals that we know that spell out a code. It's sort of like, and I know nothing about computers compared to you.
I don't know anything about DNA compared to you.
It's like if you had keys that had orange, apple, banana, kiwi, when you're trying to code for Python or whatever JavaScript or something.
Yeah.
It's it totally doesn't make sense in the system.
For sure.
So that would be one of the telltale signs. But so far, all the branches on the genetic tree come back to a certain point that we recognize to be similar. So it is the tree of life. If you think back to your dad's all the way back, there's the Y chromosome that you have. And, we can dial that back to Y atom. And in your mitochondrial cells go through the X chromosome, or their own DNA, really. But you can follow it back to mitochondrial Eve, and you can put them probably in the same place a certain time period ago.
Yeah.
But you can also relate them back to mushrooms and single-celled organisms, and they all use DNA. So there's not a completely convincing case that any of the life forms that we know are foreign aliens. Now, if they're aliens that use DNA, then maybe the life started here on Earth, came from somewhere else, maybe not. But there are comets with glycine on them. Glycine is a protein, and I believe there was a study that found glycine forming under some conditions where you have less complicated pieces, and you turn around and something complex is there. It's not like throwing all the ingredients in your fridge and then opening the oven and expecting a cake. Like there's some evidence of life and how it's related and similar, and we know how it got there.
Yeah.
At a certain point. Now, where it started, we're still not 100% sure. But this goes back to RNA world. Cells are made from genes. Genes replicate genes. Genes replicate genes. But you keep going back. There's different types of DNA. mRNA is a big thing in the news right now. So it's messenger RNA. It uses like the same ingredients as DNA. It's a little bit different. It sends a message. So you keep going back. DNA is two sides on your ladder structure.
Yeah.
RNA is just one. And so
and it's got like let's say DNA is a double helix with like long johns in the middle.
Yeah, with your twisty ladder.
Yeah, and then RNA still has like short rungs.
RNA is a single-sided ladder with rungs.
With shorter rungs. Like
with shorter rungs.
Both, like if you took two RNAs hypothetically and put them next to each other, it would be the same distance.
For the purpose
as DNA.
of this example, sure.
Yeah. Okay. Cool. I'm trying to conceptually understand.
Yeah. Basically,
I'm not trying to be a biologist.
If you have a ladder, and each of the rungs is a different size.
Yeah. Oh yeah. I'm actually remembering some things.
So like you have, let's say, two different sizes. Or let's say 4 different sizes.
Yeah. Because there's 4. What are the 4 components?
Oh, geez. Adenine.
Yeah. They're letters. Give me the letters.
A's goes with the T's, and the C's go with the G's, and the U's can be substituted for.
Yeah. I had a biology class
T's,
in high school. See, I know like 3 things.
Yeah. It's been a while since I've broken it down.
Yeah. No.
But yeah, so the early life forms. Maybe they were RNA, but RNA is really just proteins, and proteins are coded for by genes, but proteins are forming on comets out there. So, who's to say what? Maybe panspermia, life from somewhere else. Maybe biogenesis, life from abiotic factors. Who knows? I can't tell you.
What could cause these? For the sake of the question, these things that appear to be biological as far as a material sake that are abiotic.
What do you mean? So
sorry, maybe I asked the question badly. What non-biological factors could create these proteins and such life-like matter? You mentioned before that example, maybe nuclear things could, but what else do you think?
Like the proteins we talk about, biotic. They have a carbon structure. The sugar backbone deals with phosphorus. Phosphorus isn't. It's part of the whole recipe, but you can consider life. We're a carbon-based life form. We're made of carbon. Yep. Everything you eat has something to do with carbon. But water is abiotic. It's not living. It doesn't replicate. It doesn't have genes. It doesn't pass on any information. Sunlight, abiotic. But you can have water and sunlight, and a plant will grow. You know what I mean?
Yeah, I do.
Obviously,
I
there's
do.
there's
Yeah,
like
for
32
sure. I
chemicals it
understand.
needs or
Yeah.
something like that, 27 or 32. Dr. Erdley, sorry I failed you. But there are a number of elements that a plant needs.
Yeah.
Yeah, so what would cause it to form? I'm not sure. I don't have the answer, but I would imagine early life forms to have something to do with RNA. So RNA world is one of the hypotheses for life as we know it today.
And have we found RNA anywhere outside of Earth?
RNA is everywhere. You have RNA in every cell in your body right now.
Yeah, but I'm saying,
Except
have
for
we
blood
found it
and a
anywhere
couple
outside of Earth? Have we found RNA outside of Earth?
I don't believe so, no.
Okay.
We've found proteins.
Yeah, you
But
mentioned.
proteins are basically just little sticky bits of carbon.
Mm-hmm.
And they're like building blocks that help form a larger machine. So
Yeah.
basically proteins build a factory.
Ingredients in the primordial soup.
Yeah, so I sort of like to imagine cells as maybe or not just cells, but multiple cells in the same area. Let's say single-celled organisms.
Mm-hmm.
They're basically like free radical militaries, let's say. And they build their walls around them, their membranes. They build the membranes around them. They build structures that go through it. They build structures that refuse anything except for something that can bind to this. So they have a system of letting things in and out.
Mm-hmm.
And they get as prosperous as they can with food material, water, whatever the cell needs, it goes and gets from somewhere. But then it's working against all of these other factors around it.
Mm-hmm.
So when you have a cell membrane that gets broken by something, that cell's not doing so hot. It's done.
Mm-hmm.
But all the parts of those cells have structures that are made and accumulated and sort of delegated where they go by genes. If it has a nucleus, it's sort of calling the shots on where it goes, what it's doing, and like how to make the instructions. And in that nucleus of a cell, it's sending instructions out constantly everywhere. Here's what you do, here's how you do it. And it builds these little machines out of proteins and makes something else.
Yeah.
So it's a fascinating process.
No doubt.
Going from genes, codons, to proteins, genes code for proteins. And that's pretty much the blueprint that life runs on.
That's crazy stuff, man. So we got a couple more comments. I just want to check it out. Oh, we got a bunch of crazy stuff.
Uh-oh.
I'm going to just see if I can grab the questions.
Awesome.
All right, cool. So, sponsor again, Vedinian asks,
Oh.
Pure thought experiment. Do you think humanity would encounter extraterrestrial or extra-dimensional life? Do you think, like, I guess he's asking, what do you think the likelihood is that we will encounter that?
The likelihood? Right now, it's pretty low. If we, for example, start building bases on Mars and on Titan, we would have a better chance of interacting with anything because we're not just at one place, Earth.
Yeah.
So it would be interesting to build the infrastructure to be multiplanetary.
Yeah.
And at least prove that capability. Because if any intelligent life forms out there, I mean, I don't frequently talk to ants.
Yeah.
But, you know, when you consider just the lapse in, like, what it is, maybe we won't understand what they're trying to tell us.
Mm-hmm.
And they're trying to tell us a way to make better, more efficient systems or harvest energy better or use better rocket. We would have no idea what they're talking about if we're, you know, in the infancy of our spacefaring humanity.
Yes.
So, and I think this was another Neil deGrasse Tyson line, but if we're like 98% similar to a chimpanzee, but we have that 2% to push us beyond to be the humans that we are, imagine what the next life form would be, 2% beyond what we are. You know, it's small things like that that can make a big difference.
Yeah.
So a small thing like putting a base on Mars might be an invitation to aliens. Who knows? But until we get there and do it, I can't really, it'd be cool to see, but it's circular unless we go ahead and move forward with it.
Yeah. It's only speculative until we start pulling the trigger.
Yeah, so let's get that Starship up, Blue Origin. Let's get that New Glenn up and running. Rocket Lab, throw a person in, single person up to the space station or single person out to wherever. Because Rocket Lab is a small sat launcher, but I still want to see a person on top.
Yeah, that's
just
funny.
Like hunched over in the capsule. It would be interesting and cool to see these things, and we're in the literal space race right now. It's a commercial space
what's
race.
the process to get someone to the space station? How do I grab the vessel that you're in and then could get the secure vacuum seal?
Oh, there's a lot of great videos about this.
Yeah, I'm actually if you could touch on it
SpaceX
briefly.
Flew up the International Docking Adapter.
Mm-hmm.
Basically, it took a hub and made it accessible for a few different attachment points. I believe. I got to double check. Anyway, there's a whole lot of pressure seals.
Mm-hmm.
There's a whole lot of vacuum of space to hold back.
I imagine.
The space station is not pressurized to atmosphere. It's actually a little less dense. It's just easier that way. But then again, we have people in research domes on the bottom of the ocean floor doing research under that kind of pressure.
Yeah.
So, I mean, humans are resilient to a point.
Yeah.
What was the thing you wanted to touch on? I'm sorry, I blanked.
I don't even remember now. Now I want to talk about the ocean.
So the fastest docking to the International Space
Oh,
Station
yeah. That's what I was asking.
I think 3 hours and 8 minutes from the Russians.
Yeah.
It all depends on where the International
what's the
Space
process?
Station is.
Like, how do I grab the vessel that you're in when I'm in the space
two
station?
ways. You get berthed or you dock. In berthing, the vessel flies, I think, above the International Space Station and maintains orbit. There's a safe zone around the International Space Station because you are not allowed to crash into any part of that thing. You have to show control in each step of the way and certify that these systems work.
Yeah.
And as you approach, you maintain on different closer levels. Up until
That's crazy
the
to think
Canadarm.
about.
So Canada built this system. It's called fondly the Canadarm. And basically, if I had
Canadarm.
like imagine my
That's
hand
awesome.
like another set of grabbies up at my shoulder,
Mm-hmm.
and it moves around the space station like this, and it takes off from one side and moves around to the other. So the Canadarm walks itself
That's
like
badass.
an inchworm, sort of.
Yeah, for sure.
Arm over arm. So it captures a capsule and then moves it over and berths it to the station. It forces it to dock, let's say, or berths it. And then there's straight up docking, which is where, the spacecraft approaches the International Space Station and, lands right on target. And there's a fun SpaceX game with this, by the way. On the SpaceX website, you can dock a Dragon to the International Space Station. So it shows you the yaw, pitch, roll, and your thrust and things like that. So it's a fun learning experience.
That's
I'll
cool.
say
So
that.
you take control of like a virtual
That's
simulation.
Right. You have the same exact one, but nowadays everything's automated.
Yeah, that's pretty cool.
Yeah.
What do you think about like simulation theory? That we're all
living
in
in
a
a
simulation right now, yeah.
I can't disprove it, but I can't prove it either. And if you have any evidence, I'd love to see it.
Fair enough. Bambica. Oh man, we have a lot of comments
Yeah,
here.
let's run through.
I'm gonna ask my own before I go diving in,
Okay.
because there's another thing I really wanted to dive into. In your opinion, what is the best song for space? What's the theme
That
song for
song.
space?
That's different for everyone because it.
But what's Elan's?
Oh, that's a good one.
You're cruising in your Millennium Falcon. What's the song that makes you go, you know what, this is all right?
I don't know. It could be something by Cake. It could be something by Buckethead. It could be something by Daft Punk. It could go in a few different directions, but hopefully it's new and interesting, and if I'm actively doing things, not distracting from the mission.
I love that answer. I love that answer. We're going to go with that. That's fantastic. All right. Man, there's a lot going on there.
Hey, break it out. Let's run
let me see. I'm gonna ask one more of my own before I dive into that.
Going.
Yeah. So, I wanted to talk about time travel.
Time travel.
What do you think the likelihood is that humans will be able to harness time travel in any timeline? Do you think that
non-zero?
Non-zero.
But
non-zero.
That said, there are 3 ways you can time travel.
Yes.
3 ways.
You need a lot of energy for everyone.
Well, each one involves a lot of energy. Anyways, 3 ways you can time travel. None of them that I know of go backwards. I'm not familiar with tachyons, so don't ask me.
Yeah, those are the time-traveling particles.
3 ways you can time travel. Way number 1, right now, second by second, the universe is expanding. We are in a different place. The Earth is spinning. We are in motion. So the rate is 1 second per second. You're time traveling right now. You can't go back. Way number 2, you travel near the speed of light. So in a particle accelerator, they took 2 particles, they charged them up, and the charge dissipates naturally as it goes.
For sure.
Yeah, entropy and all that.
Mm-hmm.
They spin up these electrons or whatever it is, and they put one on the side in a holding chamber, and then they take one of those holding chambers and accelerate it. And accelerate it, and accelerate it up to the speed of light. And after so much time, they slow it down and measure the charge. And wouldn't you know, the one outside lost its charge at an expected rate that was measured, and the one that was accelerated did not lose as much charge. So it experienced time dilation where, moving towards the speed of light, it experienced time more slowly. Way number 2. Way number 3 to time travel is to orbit a massive object.
A black hole.
So if you go to a black hole,
massive density,
and I forget the actual numbers, but if you go let's say the Earth-Moon distance, which is like 250,000 miles, it's really not that far. 250,000. Yeah. Anyway, if you go 250,000 miles away from a supermassive black hole in your spaceship, and you orbit it for, let's say, a week, maybe back here on Earth, that might be 40 years. Another way to time travel.
Why is gravity significant in that way? Can you give me more specifics? I'm curious.
Excellent question, and there are people working on that right now.
Do you know more that you could dive into?
Clue.
No, you don't. You just know the top level stuff.
It has to do with time dilation, and Einstein was right on the dot.
Don't they say that the laws of physics work except for 2 places, right? What you just described.
There's a few different. So there's like physics in our world.
Yeah.
There's Newtonian physics.
Mm-hmm.
There's quantum, which is real tiny, small. Then I guess nuclear fits in with that. And outside of that, there's like dark matter that we have no idea about. Remember that sponge model with Laniakea, and all of the galaxies are in those strands in the sponge? Well, in the space in between, there's dark matter, and we have no idea how that works.
Yeah, and most of our universe is that matter.
What we see right now, but we only call it dark because we don't know what it is, how it works, or what it's made of.
Yeah, I remember I heard, maybe it was Michio Kaku, but I don't want to say it was for the sake of argument, but I think they were saying it's less like matter and more like energy.
Okay.
Yeah,
I would accept that because I have no idea.
Yeah, well, I think the reasoning behind that was something to the effect of the way that it affects matter that we do measure is more akin to the way sources of energy do. I don't want to butcher it, but it's not the way that
We're
matter.
We're going to have to dig up some links after this.
Yeah, for sure. We can definitely crack open another brewski on it. But yeah, let me jump in here. We got a bunch of questions here. Guys, make sure you subscribe too, all you commenters.
Yeah, before we go on, hit like, subscribe.
Yeah.
Check out the Bardic Inspiration Podcast.
Absolutely. Thank you very much. And make sure you guys follow Elan on Twitter. That's your main one. That's the one you monitor the most frequently.
There's also a Twitter for Berks Astronomy. I don't use that as much, but you can always reach me that way. BerksAstronomy@gmail.com, ElanLift@gmail.com. it's all at Elan Lift for Twitter, for Facebook, for Instagram, for Venmo or PayPal, or I'm working on the Patreon thing. We'll see where that goes. But it'll come together at some point. But you can always find me Elan Lift. Also, if you Google that, there's a great company making stair chair lifts. Elan Lifts.
Yeah, that's so funny.
Good luck Googling me. But you can find me at Elan Lift.
That's so funny.
Yeah. You got to hit them up for something.
Yeah,
we got to sit down and have a conversation.
Yeah, seriously. It's like, you got to be my sponsor or something. All right, let me take a look at here. All right, I'm just going to pull up the questions. All right, cool. All right, nice. Yeah, so basically they're just commenting on our previous discussion about the two time travel stuff. Okay. But I liked your third example of we're going at 1-to-1 ratio time travel right now.
The first way we're all time traveling right now, second by second. That is way number one. So you have to start from somewhere, and it's the way that we know, and you can't go backward in time. We talk about that.
Well, there's another like theory I've heard. Maybe you can touch on it a little bit. But that wormholes could maybe enter you into a maybe even parallel universe or something like that. This is all speculation here.
I'd love to see it. I have no idea.
No evidence and all that. But I'm saying
I have no idea. So another thing about that, like a black hole sucks things in.
Yeah.
Apparently things come out with some sort of information. Not all information is lost in a black hole. I know nothing about that. Hawking radiation has happened in our lifetimes.
What is that? Hawking radiation?
Black holes actually emit energy and lose it, and it radiates away, so that a black hole isn't just constantly feeding. And they started to describe the process of how black holes gorge and then just chill, and then gorge and chill and gorge and chill. And also somewhere in that process they radiate away. And so Stephen Hawking,
I've seen it where it's the strings that
the spires
it emits,
that come out the jets.
They're very thin, right? It's a very thin.
I wish I knew more. I'd love to know more about that. But
I think I've seen
Wikipedia for that.
for sure. Fair enough. They call that what, the Hawking
radiation is how black holes can lose energy.
Is that because Stephen Hawking discovered it or something like that?
That's right.
Yep, cool.
And the flip side of that coin, in the math, if that works, then the opposite is true, where a white hole can be formed.
I've heard of this.
So that's one more thing.
That's interesting stuff.
Yeah.
That's interesting stuff. But we haven't seen a white hole.
Not to my knowledge, no.
Yeah. Okay, interesting.
We've not seen it observed in nature. The nature of white holes, wormholes, quantum leaps, teleportation.
Yeah.
I'd love to see it, but we have yet to see the data.
Yeah. What do you think is the most powerful force on humanity that has come from the space race as far as technological innovation, something that affects people's lives every day?
Kindness.
Once
upon a time, we were in a nuclear arms race. I think it was the Russians that went and blew up a nuke in space, knocked out a whole bunch of electronics.
The EMP thing, yeah.
And threw a bunch of things out of whack, and they said, whoa, let's not do that. Let's not do that again.
Yeah.
So, with the space race, it sort of coincided with the nuclear age and the research and technology and everything. And, rockets are exactly that. They're rockets. But we're putting scientific payloads on top of them. We're not putting
warheads.
Warhead. That would make it a ballistic missile, and the jump is not very far to do that. But it's seeking the peace in between, and that's a decision that's been made. We're not living in a nuclear winter right now, and I'm thankful for that. I am so thankful.
Definitely.
But back in the Cold War days, that was a serious concern. And the kindness that has spread through the space age, has brought that stability, if you could call it that, at least to this age, where now we have, American astronauts and Russian astronauts on the same space vehicle for the past 20 years, continuously occupying the International Space Station. So that's probably the force holding things together, because without that little bit of courtesy, things fall apart pretty quick.
Yeah, I've watched and listened to many sources of media on the topic, and the Cold War was certainly a scary time. It's funny how there were treaties put together. I don't want to say it was NATO because I don't want to be wrong, but eventually after that incident, and I believe there was another one in the ocean that had caused some problems, they had all the countries in this debacle had agreed to no longer do nuclear testing offshore.
Underwater.
Well, outside of their boundaries.
Oh, okay.
Right. So if maybe I wanted to stir the pot a little bit, I would just launch a nuke into no man's land in the ocean, knowing that it's going to cause a tsunami to hit Hawaii or something, you know?
Yeah, that's horrifying.
It is, very.
Sure.
But eventually they decided we're just going to agree to keep it in-house. And then I remember the American government, there's a story where they were trying to approach companies to say, hey, let us use our nuclear weapons to help you clear this quarry or something. It'll, be a better alternative than, whatever mining equipment you might have used. It'll be a cheaper thing, and you're going to be helping the government. And then the nuclear explosion ended up contaminating the resource at that quarry. It's crazy stuff, man. It's very crazy stuff, man.
I think it was either northeast U.S. or somewhere in Canada. Kodak Film was, doing their film thing.
I know this story, please.
There's a great YouTube video about this, or story you can read about it. But all of the X-ray film was coming out really poor. It looks like it was already exposed, and doctors need the X-rays to be right. And they were. It turns out, after the hush about all of the nuclear tests, turns out they were using wood that was harvested after these nuclear tests that ends up in the boxes or like some part of the film.
Yeah.
And so the film was getting exposed from that radiation. And so like the film industry knew about the nuclear tests before the American public.
Yeah.
But they were told to keep quiet. And like there's all these crazy stories about nuclear arms testing.
Mm-hmm.
And I think it's scary to see the potential, but I also see the potential in using it for good, where you can hold the entire energy use you would need in the palm of your hand in uranium or whatever it is.
Mm-hmm.
Like there's better ways to do things, and I like to keep the optimism there, and hopefully one day we can all work together and use better systems to achieve bigger, better things.
Hell yeah, bro. That's awesome. Let me just double check here. It is getting a little late. I don't know if you have like a curfew here. It looks like we're at 10:30.
Turn into a pumpkin.
So let me double check on any of these questions here.
Yeah, any questions, I'll do my best to answer. But again, I am no expert.
Okay, all right. Vedinian has another question here. Speculation. If an extraterrestrial life form was found to be silicon-based, what is something that could give it energy?
That's an excellent question that I don't have the answer to. If it's silicon-based, I got to look at a periodic table. I mean, I've seen the movie Evolution.
Yeah, that's kind of what I was thinking when he brought that up.
It's a fun little movie. It's ridiculous, but also hilarious.
Awesome.
At that.
It is.
Yeah,
I love that movie.
Includes some scientific elements into it.
Yeah.
What if something was silicon based? What was the question?
What would give it energy?
I'm not sure.
We're carbon based, right? So.
But we're still getting energy from the things that we eat, which is ultimately produced by the sun. So
makes sense. So other carbon-based life forms, right? So you would get maybe speculation, right? Like this makes sense to me that maybe if there's some sort of silicon life form that gets energy from the sun, you would get energy from that.
Yeah, whatever energy source there is. If you're tearing apart uranium to make energy, you're still using uranium, which was formed in the crucibles of stars, or in like stellar formation or destruction. So you're still using something based on the sun. So ultimately it comes from stars, but we can still use other energy sources. Like we eat cows, which eat grass, which get their energy from the sun. So it's a game of down the chain it goes. But if it's a silicon-based life form, it's probably getting the silicon from something else that used the energy from the sun at some point.
Or maybe energy from a vent under the ocean or something like this.
Of the Earth, which is heated not only by the pressures around it, but in that formation of all these rocks come together to form the Earth around the sun.
Hell yeah.
So
awesome.
It comes back to it. It's sort of a daisy-chained explanation, but
great question, though.
Ultimately,
great
I
question.
don't have a specific answer for that.
All right, man. Well, we're almost at 3 hours. Do you want to keep running? Do you want to kind of keep shooting from the hip on some stuff?
How many questions do we have? I don't want to...
That was pretty much it. That was
questions.
pretty much it, as
Okay.
from what I see here. Do you want to talk about anything specific? I know you're doing new work these days. Maybe let's talk a little bit about Elan. Like, how has the quarantine affected you here on Earth?
So I got married during the quarantine. I couldn't invite as many people as I would have wished, but I was glad to see, family and friends join the Zoom and get married in the in-laws' backyard. We spent, months and months preparing it, which was, fun working outdoors. And I was quarantining with, my in-laws. And between working the essential jobs I did at the time, as soon as the pandemic hit, I started manufacturing disinfectants with a local company, the only one that does it in Berks. And then I continued with the radio gig that I've been doing, which was a lot of fun. Totally check us out. So I'm a host on Talk It Out, which happens weekdays, Monday to Friday on 8:30 a.m. WEEU. So it's a whole lot of fun to jump into radio. And it started off as like a hobby.
Yeah.
Like it's fun to do this radio show, and it turned into like it's still fun to do, but now it's like
you're getting paid to do it.
Well, weekly,
not
just once
like
a week,
consistently,
not just a space report, but I'm on there. Of
You're
course, I'm talking
talk
about
show.
space anyway.
Yeah.
And but we'll also talk out current events, things like that, news stories. It's fun to keep up, but I also think that our local news coverage, or not local, our news coverage in the United States lacks space and science and like cool infrastructure things. So I hope I bring that to the table well enough. But shout out to my radio family at WEEU.
Heck yeah, man.
So feel free to call in.
I remember we actually called in the other day after we did a cold plunge in a pond in, I believe it was Wernersville or some such place close
Sure.
by.
Well, it comes through on the airwaves with AM radio. It's in the area, but it's also at 830weeu.com.
Oh,
and so
nice.
you can check it out, and always feel free to call in and talk it out, whether it's about space or jumping into a river and what that does, or a pond or whatever it is.
To the body.
And the icy temperatures that might invigorate you, but also don't get hypothermia, please.
All right. That's awesome. So,
got married during the pandemic.
Yeah.
Sorry, I don't want to cut you off.
No, for sure. I was just gonna.
Running through.
I was gonna recap everything you said and ask what else.
I love living with my wife. It's wonderful. Like the time that we get to spend together, we get to talk more. We haven't gotten annoyed with each other or anything like that. In a fun way, I annoy her.
Course.
Of course I do with my
need to.
nerdy,
It keeps
geeky,
it fresh.
whatever. What movie are we going to watch tonight? And I had never seen Contact, so of course I had to watch that. She was like, oh, it's another geeky space movie. She likes some of them, but of course I always push the envelope with that and comedies. I was doing I I was attending open mics through the music
Yes.
scene, and I love the music scene. Anywhere, live music is always great.
Yeah.
If you produce your own music, I think that's wonderful. And while I encourage any kid to go into science and technology and engineering and math, those are hard-hitting subjects, and you can't just do those things. You got to put some arts into it too. So full steam ahead.
Mm-hmm.
There's lots of music out there, and I think through the pandemic of COVID-19, music has suffered in a way because there's not as much collaboration between artists, but also it may have forced some artists to get more creative in other ways. And artists sort of had the edge on that, where you're finding creative solutions,
Yes.
using systems we've never used before, like Zoom.
Yeah.
Right?
Yeah. No,
That's a
I
simple one,
definitely can say that as a creator myself, leaps and bounds have been developed in my knack or my niche, whatever you want to call
so
it.
kudos to you for pulling through on that and
Yeah.
setting stuff like this up. It's really awesome to see what people have done. It's heartbreaking to see some of the pain people go through in these
For sure.
situations.
Depression has been rampant.
Mental health's a real thing. Keep hydrated, take good care of yourself, and that doesn't just mean do a bunch of push-ups and sit-ups and eat healthy. It also is, take a mental health check-in. Like, there are online therapy things you can do. I use astronomy as therapy just because the further you look out in space, the smaller all the problems on the ground. And it helps me bring some of that worldview in and really, see everyone as an equal human walking around on Earth. So it's a little bit of that overview effect, the worldview that astronauts might talk about. Other things to talk about. Change the city flag. I think the city flag should represent people. There's a great talk by Roman Mars from the 99% Invisible podcast, who gives a 20-minute talk on why city flags are important, why flags are important, and why you should go look up your own city's flag, and if it sucks, you should change
Petition to get it changed. Yeah.
Yeah,
That's
and
cool.
so however you do that, there's some examples out there.
If it sucks.
Yeah. So if you have two cavemen
Yeah.
and a salamander on fire for good luck on your flag, that's cool, but it's not my style. So it's one of those things that, flags represent the people, and if you want to get people together to unite and conquer a problem, you can do it under a flag, let's say. So
the symbolism is really important. That's awesome. So let me ask you this. This is actually a question I'm curious about. Obviously, your day-to-day and your entertainment has been severely affected. I haven't been living in the Reading area for practically all of 2020. But I'm curious, what is there to do? Maybe we're locked down again, but
Sure.
a month ago, what was there to do? What sprung back up? Are there any open mics around? I don't know.
So,
I know mine that I was hosting is not. I haven't heard anything from the Speckled Hen.
well, there's the Berks County Quarantine open mic.
Of course,
that's a great group.
I was on there for a while in the beginning of quarantine.
There's
I was
also,
jumping on it.
I was checking out not just open mics for music, but open mics for comedy as
Yes.
well. A comedian can take something dark and poke a little fun at it, poke some holes in it, and hopefully you get to laugh by the end of the set. Now that disclaimer, parental guidance, I guess. Let's say go along with what makes sense, not with what they're talking about or what they're doing, because it might be a little bit crazy.
Yeah. Any comedians specifically that you were checking out? I have some examples if you don't.
I can't think of any comedians off the top of my head.
Mark Normand. Do you know who that is? He's one of
I'm
my
not sure.
favorite comedians right now. But he was doing this thing called Park Normand, where he was going out and doing open air, social distanced comedy in a park.
That's awesome.
And then parking lot Normand. It was comedy
it's
to cars.
creative, and that's awesome that he's able to do that. So shout out to the creativity that it takes to pull something like that off.
I know a lot of comedians were they're not doing anything while this is going on. And then alternatively, you have guys like Dave Chappelle who were going out, getting a spot, and making sure everyone who attended had been cleared medically before they can attend the show, so that there was no chance of COVID being in there.
Yeah, there's stuff you can do. For example, coming up on, and this is coming up in a week, December 21st is a planetary conjunction of Jupiter and Saturn, where they're going to be within, 0.1 degrees of each other.
You have a telescope?
And so with my telescope, I'm able to split it. But the
Dude, we're checking that out. I'm coming. I'm
well,
coming to your crib that night.
I might not be able to do certain things.
Oh, man.
So with a telescope, you can split it, but you can see them with your eyes. There are 5 visible planets.
Yeah.
Mercury, Venus, skip Earth, Mars, Jupiter, Saturn. You can see all 5 of these planets with just your eyes. You don't need a telescope. You don't need binoculars. But with binoculars, you may be able to split Jupiter and Saturn apart. You might not see the rings of Saturn, but you might be able to make it look like an elongated smear. And then with the telescope, we're going for splitting Jupiter and Saturn, all, 6 arc seconds across. So it's really just the lining up of Jupiter and Saturn. Every 20 years they go around. There's a conjunction every 20 years. A year on Jupiter, I think, is 12 years. A year on Saturn,
like one revolution. Is 12 of ours.
12 Earth years
for Jupiter.
And I think Saturn is something like 29 years.
Oh wow!
So the way the math works out, every 20 years is a Jupiter-Saturn conjunction, and so we just have a really close one. Next time it's going to be this close is 2080. The last time it was this close was a couple hundred years ago. So we're lucky to be able to see it, and you got to enjoy the things as they come. Any dark, clear night, keep your eye on the sky. Look out for shooting stars. Even if you know nothing about astronomy, grab a pair of binoculars and take a look. Start to, really look into your night sky or what's out there. There's a couple books you can look into, some online software. And if you don't have access to any of that, you can simply walk outside and look up. Remember to bundle up and bring something warm to drink. It's always good to have like a hot chocolate just to keep you warm through the night because it gets brutally cold. No doubt. That said, I've been on mountaintops where there's almost 30 people out there with telescopes and 1.5 feet of snow on the ground, and it's 16 degrees.
That's gangster. Yeah, lots of hand warmers in those pockets.
I didn't have hand warmers that night, but I was comfortable.
I believe it.
Yeah, it was brutally cold, but it was awesome because there was so much energy and excitement for seeing the things that we saw. And in the wintertime, yes, it's colder, but the air is thinner, holds less moisture, so you have a clearer view. There's less scintillation or the back and forth movement of particles. So
that's interesting.
Yeah, so definitely take a look at your clear, dark sky. If you're looking for shooting stars, give it time. You got to go out there and commit to being out for, almost, let's say, 20 minutes to let your eyes adjust, and then whatever time on top of that. You're not guaranteed to see a shooting star, but you have to be looking up in order to see one. So it's a random chance that it happens. You just have increased chances, especially with the peaks of meteor showers. Yeah. So we're rolling off
that non-zero.
Exactly.
The more you're looking up.
Non-zero. The Geminids are rolling through. The Ursids are coming up. You're going to see meteors every night, but it's a matter of getting outside in clear, dark skies and reducing your light pollution. If you have a neighbor who has lights, please talk to them. Mail them a letter, whatever you got to do. But if you have to take it up to town ordinances, definitely do that as well. I know in the city of Reading, they have good light pollution laws, and light trespass is taken seriously. But there's also a handful of municipal buildings that are not held to those standards. So there's more to do because light pollution is a resource that we are losing, and as more Starlink satellites cloud out whatever's beyond and ruin photography, and as more infrastructure is built with more lights, even if it has responsible lights facing down at a parking lot, that still reflects back up into space, so it reduces your ability to see the night sky. The International Dark Sky Association.
Can you say where in Berks County is your favorite place to go to get the dark?
The Berks County Amateur Astronomical Society has several locations that it uses. If you are a member, you can use them.
My man.
That said,
way to plug it.
That said, awesome. There's a few good resources. So check out lightpollutionmap.info. And all these links are at the berksastronomy.org page. Lightpollutionmap.info shows you where the light pollution is, what may work around you, and it's updated every year. The Pennsylvania Outdoor Lighting Council integrates information from the International Dark Sky Association, so IDA.org, I think, is that one. The International Dark Sky Association. Cherry Springs is a Pennsylvania resource, 4 hours from Reading, 3.5 maybe. It depends on who's driving. Where it is a dark sky reserve park. However, no matter how dark it is in that area in Potter County, in that Black Forest State Park, if there's a city, right outside that border that's not held to that standard, it ruins it for everyone. So keep track of light pollution because it's a natural resource that we don't get back. Also with that, NASA does a whole lot of great stuff. There's NOAA, the National Oceanic and I think Atmospheric Observings.
Yeah.
Observations. Anyway, whatever NOAA stands for, they do a bunch of great stuff. Take care of your environment because it's also one of those natural resources. And the more you take care of it, the more Earth we have to share.
Yeah.
Because it is a finite resource. Even though we might be able to pay for things now, of course, we all see those increasing prices. And climate change has a lot to do with that. So, be good stewards.
We're going to pay one way or another, rather.
Yeah, be good stewards of the earth. And you got to take care of what you can while you can. So I've been doing a little bit of work and research trying to round up all the light pollution odds and ends and, go to each of the municipalities and Berks and see what I can do for lighting ordinances. That said, feel free to use any of those resources: Pennsylvania Outdoor Lighting Council, lightpollutionmap.info, International Dark Sky Association. There's globeatnight.org. There's a fun little app where you know what the Big Dipper looks like, right?
Yes.
Well, there are other stars in there. And when you get to a darker sky, you see more. When you get to an even darker sky, you've upped the contrast. So you see not further stars, but dimmer stars. And also galaxies are very dim too. You get to see those better and better as the light pollution drops. So globeatnight.org, there's a fun little web app on there so you can mark, I see this number of stars, or I see the next map, and out of the 8 tiles, how many of these stars do you see? Well, if you see more, then you go to the next tile. Do you see those? You go to the next one, and so on and so forth until you either move one way or the other, or you select your one of the 8 tiles to help track how light pollution is changing. So definitely keep track of light pollution, and just be good stewards of the earth.
Yeah, man. Yeah. That's awesome, man. I'm going to just double check, see if we have any questions here.
Comments. And that website was berksastronomy.org.
That's awesome. So Vedinian has one final question for you, Elan. He says, do you think a planet can orbit a dual sun system and still be in the gridlock zone?
In the Goldilocks zone, yeah, absolutely. So double star systems are very, very common.
I'm sorry there. Yeah, okay.
So actually right now, in our winter skies in the northern hemisphere, we see rising from the east Orion, just probably slightly south of east, rising from the east, setting towards the west. Orion's on the rise. The 3 stars for his belt, if you draw a line in the southeast direction, you find Sirius, the brightest star as seen from Earth aside from the sun. In the opposite direction, you pass Taurus the Bull, that V shape, the Hyades cluster, and then you find the Pleiades. Well, the Pleiades is a cluster of stars held outside of the Milky Way, but it tracks along with it as we all spin. It's just outside of it, but this little glob of stars moves along with us. Now, it's a whole bunch of small ancient stars. There's, I don't know, with your eyes you can see maybe 7. They call them the 7 sisters.
Yes.
With binoculars you see
one
the 50.
One of your exhibits, I remember. Yeah. That's how I know the Pleiades.
And with a telescope you can see something like almost 500 of the how many thousand are in there. But it's a multiple star system held together by a mutual gravity. Now, are there planets there? I'm not sure. I don't think so. But it's possible for stars to eject planets. So rogue planets, they sort of catch a gravitational wave and ride it out so that they lose their parent star and they freeze. So rogue planets.
Whoa!
do
So like
exist.
the planetary object rotates around the sun, and like the gravitational pull gets removed, and it just flies off.
You ever jump on a trampoline?
Yeah.
Ever catch a bounce off of someone else's jump?
Yeah.
A little bit
More
like
like that. Okay.
A little bit like that. Not exactly.
Yeah.
There's way more involved.
Yeah, I'm sure, but good
yeah,
example.
you're changing parts of the system. So that said, you can have star systems where you have 2, 3, 5 stars orbiting each other. Double star systems are fairly common, I believe. I got to look up the numbers, but absolutely, it's possible to have, the double sunrise that Anakin saw.
Mm-hmm.
Probably not like that. They would rise and set at similar times.
Interesting stuff.
And the Goldilocks zone is just, can we maintain liquid water on the surface of the planet?
Mm-hmm.
And so it's not too far away that all the water freezes. It's not too close that all the water's gaseous.
Boils, yeah.
And somewhere in between the Goldilocks zone, it's
how
just
how
right.
how big is the Goldilocks zone?
Mars is just on the outside. Venus is just on the inside. But Earth is just right.
So whatever the distance between those two.
And it varies star to star. If
Makes
you're
sense.
talking about a small dwarf star like the TRAPPIST system, TRAPPIST, I forget the numbers behind it.
Yeah.
Basically,
Then Mercury
there's
might look like a good
there's
spot.
a very dim, like I think red dwarf star, not too far away from our sun, but far enough to make it pretty far. There are 7 planets, all huddled in real close, and they're all tidally locked. The same side always faces towards that star, but there's like 3 or 4 in the Goldilocks zone there, where it can maintain liquid water, probably on one of the edges. They call them eyeball planets just because it's roasted on one side, frozen on the other. So the side facing the star takes on that eyeball appearance.
Interesting.
Yeah, so it's possible to have rogue planets. It's possible to have multiple star systems that maintain planets in that Goldilocks zone. And boy, are we lucky to be in one. That said, the sun has another 5 billion years on it, let's say. Maybe it's 5 billion years into its solar cycle, into its the whole scheme of it, into its life, the star's life.
So our sun dies in 5 billion years.
Well, sure.
Yeah. It changes.
That said,
yeah. Doesn't the death of the star expand?
The core will condense, the outer layers will expand and blow off eventually.
When does that happen? How many billions of years or millions?
That's a good question. I
You
don't
don't
have
know.
the numbers
Okay.
in front of me, but I
So
do
good.
know that in like 100,000 years, the water will boil off of Earth.
100,000?
Yeah, it's much faster than the death of the star. All the water, the oceans will boil off much sooner than,
That. Yeah.
it's something like 700 something billion or 700 something million years, or 700 something thousand years. There's some number in there where, we're toying with that line now.
We better figure out how to
whether
get
it's
off.
a little further away or a little bit closer to now. So the oceans eventually will boil off. That said, there's a lot of factors in the short term, like as we heat up, things get worse and worse. But once Yellowstone erupts and clouds over the sky for a few years and brings on the next ice age, it may be a phase of Earth that gets triggered, but the ultimate trend is that the solar system is heating up as the sun literally blows away its outer layers at everything around it, expands and eats all the inner planets.
That is some heavy stuff there, Elan.
Yeah, well, it's far off in the future. And
so how long do we have to figure out how to become like the next type civilization to become multiplanetary?
I don't know, but it's a good idea to start practicing now.
I'll drink to that, man.
Yeah, it's a good idea to start practicing now. So here.
Yeah, definitely, man. All right, man, that's awesome. So that's the end of the questions. Do you have anything else you want to pop out? Any last shout outs?
Feel free to shout out to me at like Facebook, Twitter, Instagram at Elan Lift, ELAN LIFT.
And anyone who's watching also, that's under his name, all those things you can locate Elan via
so
those.
check that sidebar or the description underneath for all that info. For the Berks County Amateur Astronomical Society, berksastronomy.org. That's BERKS astronomy.org. A lot of fun resources on there. We do monthly meetings every second Thursday. That's our official meeting. And then every fourth Thursday is like a hangout, catch up, look at these news articles, let's chat about this or that or the other, similar to what we've done here tonight. So,
and how hard is it to get into the club?
Well, those meetings are free and open to the public. You can check it out, grab it off the website, berksastronomy.org. Membership is, it's free for you, cheap for them. You can always attend a meeting, but if you take on membership, then you get access to a few more things. So it's a lot of fun to continue with the Berks County Amateur Astronomical Society. We have lots of fun with telescopes.
No doubt.
And you get access to some big telescopes.
Oh, really cool, really cool. I guess you got to give me a little tour then, maybe. That should be a good after show or something. We'll see. Yeah. All right. All right, brother. Definitely make sure you guys follow Elan and check out the Astronomy Club. I guess we'll call that a wrap. Thanks for coming on the show, brother.
Thanks for having me. It's been a pleasure, and I've enjoyed being on the Bardic Inspiration Podcast.
Yes, sir. And it's been a pleasure myself, homie. Peace. Have a good one, guys.
Take care.